So all what we have done already, that data was available and we were in position of creating or developing it into a model, but that model will not take any final shape until and unless it is put together. So here in develop schedule, we'll put together all that data, further analyze it and convert it into a schedule, the bar chart, the Gantt chart. The key benefit of this process is that by entering these schedule activities, the durations, the resource availabilities, the logical relationships, all that we have done into the scheduling tool. Now we are putting it into the scheduling tool, which will generate the ultimate model, the schedule model, with exact planned dates, when to start an activity, when to finish an activity, and then we will put it all together into our Gantt chart, our bar chart. This process is performed throughout the project because uh, whenever there is a change, we will have to tweak that model and recreate our bar chart. And that's how, throughout the life of the project, this schedule would be coming up with new baselines, right? And we will continue till the end of the project. This schedule can change anytime during this life of this project. Now let's look at what are the various inputs, tools, and techniques and outputs. So all the data we had created already that would appear as our input, like we will have, as far as the management plan is concerned, we will have the schedule management plan and the scope baseline. These are the basic documents which we start with. Then we will have other project documents which we have created and stored in our document archive. These were, we had calculated the activity attributes, activity names and list, assumption log, basis of estimate, whatever we have, established the rules for calculation, duration estimates, lessons learned, milestone list, schedule network diagram without any critical path, team assignments, that the resources, the physical, human resources are, when are they going to be available? Resource calendar, again, this team assignments are put into a resource calendar, which tells us when who will be available. Resource requirements, that is from the project side, when project needs what resources, and if there is any risk, then the risk register can also help us out. For doing all that, we may resort to certain agreements. For example, we do not have enough resources within the organization. They may be living or non-living resources, human or equipment. So we may have to get those things from outside, and that is going to happen through an agreement or a contract or something like that. So there might be certain things which are not available within the organization, so they will be covered under the agreements, right? Then we will also look back at the enterprise environmental factors, like things from outside of the organization which are impacting us. We look at the organizational process assets as the old record, old project, how we have done things there, how we created the schedule. That will also serve as a lesson learned to us. This is all what is input. And now is the interesting part. What are our specific tools to develop this schedule? As you see, we have to very thoroughly analyze the network diagram which was created in sequencing. So schedule network analysis has to be done. Then we will resort to the second step, that would be creating a critical path. Critical path method is a tool of developing the schedule, and it has nothing to do with sequencing. Although we did discuss it during the sequencing, that was because I wanted to tell you the relationship, how this data is converted into a schedule. But basically, this thing happens during this process and not that process. critical path method is utilized here during the develop schedule. Then resource optimization. You see, resource requirements and resource availability all is input, and now we have to put those resources in to use in such a manner that they are optimized. We can make maximum use of minimum resources.
Mhm.
Then we have to do a lot of data analysis. A lot many other things are impacting. If resources are overloaded, what do we have enough equipment and materials for that? If not, then naturally all the data has to be thoroughly analyzed. Of this, we can reach this optimization level. For that, we may conduct certain what if scenario analysis. That is like a risk management within the scheduling. What if this happens, then what will we do? What would be our solution? So what if scenarios will be created, and we will accommodate them in our resource optimization. We will sometimes when we are not sure how the things will turn out, we will simulate them on some kind of environment, like maybe on computer or
Mhm.
some other means. We'll simulate it, we'll experiment with it, and then we decide what to do.
Mhm.
Then we apply leads and lags, which we have already studied during the sequencing, the concept of what is a lead and what is a lag. Lag is a gap between two activities which can be caused, and lead is overlap between two activities. That is, before the end of one activity, you can start the next activity. With the overlap of 1 day, 2 day, or whatever, that is lead. And if there is a gap, which would be called a lag.
Mhm.
Schedule compression. Uh, I think we studied about the schedule compression techniques.
Mhm.
So those schedule compression techniques will be used here to further compress and finalize the schedule, because
Mhm.
naturally when we did that, that was only the data available. We could not have really done a lot of compression there. Now,
Mhm.
because everything is here, critical path has been created. Now we can compress the schedule in the very true sense. You remember we did talk about a PMIS, Project Management Information System. This is a
Yeah.
automated system created for your project. It could be a
Mhm.
Microsoft project. It could be some other software, some company software
Mhm.
you are using. So
Mhm.
PMIS holds all the data for your project. So this could also help you in crunching that data and ultimately coming to the final shape. And in case you are doing a agile project, then
Mhm.
naturally there is a different way of planning it. So in that case, you would resort to agile release planning. These are the various tools you would be
Mhm.
using during the develop schedule. And the result would be the finalized schedule, which we call the schedule baseline.
Mhm.
And what is the difference between a finalized schedule, a schedule baseline, and a project schedule? Project schedule is a
Mhm.
generic term, and you remember that I told you project
Mhm.
schedule goes through many, revisions,
Mhm.
right? The very first time it is formed, this is not the final shape. During this process, you would be optimizing the resources, you would be applying the schedule compression techniques, due to which your schedule will, with every effort, will change accordingly, will be optimized. And as those various versions of the schedule are being created, they
Mhm.
all come under the project schedule. But project schedule, what we called it, we call them instances. Those are the project schedule model instances. We
Mhm.
may keep creating tens and hundreds of them, but they are not final until we come to a agreed baseline
Listen,
that this is the final shape of schedule which
Mhm.
could be physically executed.
Mhm.
That shape we will present to the higher authorities
Mhm.
and get their approval. as they give us the approval, they become the schedule baseline. So project schedule, by that I mean various instances of the schedule which have been created during the analysis, and the final version which have been approved is called the schedule baseline. All the data which was, it was like, I said, you fill in air into a balloon. So this data is the air in the balloon. Model is the balloon, and data is the air. Now you fill in this data into the schedule. So basically, we had all that data calculated in our previous activities, and there we have kind of the names of activities, the durations, and this and that. That is all data. So data and instances of the various schedules finally forming up into a schedule baseline, which is the approved version of the schedule, which could be executed. What else? As a result of that, we could come up with the project calendar, exact dates to be displayed to different people when what is to be done. That is called the project calendar. Change request, as you know, this schedule, whatever we finalize, our baseline, may not be staying that way. Things and circumstances change, and based on that, we have to move certain change requests, and based on that, the baseline can also be changed. So change request is a common element which will actually result in changes to the baseline. And again, this is how we keep rotating around. We revolving in this process, and we keep refining our schedule. When we have the approval of a change request, the schedule is baseline, our project management plan and our project documents will also be updated accordingly. Right? See here, we started with the inputs, project management plan and project documents. Now, after doing this process, these documents may be updated. Right? That's why they are mentioned here in the output as well. Now that we understand it, let us look at how those things are operating. Very easily, it is understandable. We are talking about the develop schedule process. It is getting its input from the project management plan, and these things are coming from the project management plan. Project documents, these are all other documents which were created during the planning, but they were not part of project management plan, because project management plan will always have the management plans and the baselines. So the relevant baselines are schedule management plan and the scope baseline. So these we are using. From the project documents, we are using all of these documents which were created during the previous processes. Then we are conducting the procurements for those items or people who have to be outsourced or who have to be hired or subcontracted. That will result in agreements. Those agreements will form input to the developed schedule process. From the overall organization or enterprise, we would be affected by certain factors like enterprise environmental factors and organizational processes. This is the explanation of what I have just shown you in a tabular form. So what all the processing which is not described here is done here within this box, converting it into the baseline and all. So what all comes out of this process, develop schedule, the final version of the schedule comes out of it, and that becomes part of the project management plan, because this is the first time the schedule baseline is created. So it will go to the project management plan. Previously, it did not have a schedule baseline. We created it now. It only had the schedule management plan and scope baseline so far, based on which we did this process, and we created a schedule baseline after approval from the higher management, and therefore schedule baseline has now become part of the project management plan. In addition to that, while we were doing that, we may have resulted in certain updates to the schedule management plan and the cost baseline, meaning whatever the schedule is, it is so far we have not studied the cost, and we are not studying the cost here. But cost management is also one of the knowledge areas which is happening in parallel. Resource management is another knowledge area which is also happening in parallel. So
Mhm.
basically, whatever the scope schedule baseline is going to impact the cost. And therefore, cost baseline will also be uh, updated into the project management plan. Uh, any change request from the baseline version, because once a baseline has been created, we have no authority whatsoever to make any changes to that. And to make any change, we have to launch a change request to the same bosses who
Mhm.
approved the schedule baseline and
Mhm.
ask them with reason why we want something to change. So we
Mhm.
have to launch a change request which goes to this process, which we will not really study here, but this is the integration process, perform
Mhm.
integrated change control. This is
Mhm.
responsible for receiving all the change requests. So all the change requests related to schedule are coming from that point, but
Mhm.
other knowledge areas are also sending them the change requests, like the scope, all the baselines, wherever there is a baseline, there is a scope baseline. So scope baseline may also be altered through a change request, right? Or the cost baseline may also be altered through a change request, but that is not our concern right now. All the
Mhm.
change requests from whichever baseline they are being created, they are going to perform integrated change control. They analyze it, they process it, and they give you the approval. Once they give you the approval, resultantly, your schedule baseline, cost baseline, or scope baseline can be updated, right? But this is outside of this chart.
Mhm.
As far as the schedule data and the project calendars are concerned, which we use as an input to create the schedule baseline, they are no
Mhm.
more required by us because everything of practical use has been put into the baseline, into the Gantt chart. Therefore, all this data can be submitted to project documents. So it is being submitted to project documents, project schedule,
Mhm.
all the data and all the calendars, they all have been updated into the project document. So they
Mhm.
get added to the project document. Moreover, the items we have considered as an input here, which were already there in the project document, may also be
Mhm.
altered and updated, and they
Mhm.
can also be updated into the project document. So these things we have used as an input, and we are, after updation, we are
Mhm.
also putting them down back into the project documents.
Mhm.
I think that is pretty clear.
Yeah, yes, sir. Very extensive. Very, very, yeah. Cool.
Now, you see, I have already told you that
Mhm.
this process is iterative in nature. First time
Mhm.
that project schedule is developed, a baseline is created. But throughout the life of the project, due to the iterative nature of the project, the things may change, the
Mhm.
situations may change, and they may have to create changes to the model. And ultimately,
Mhm.
project schedule may be change request can be moved from new project schedule may arise, so this is going to be happening, as I said before, it is continuous process. The change
Mhm.
requests will keep coming. The schedule will always keep updating. New baselines will come out. Latest baselines will come out until it will keep happening until the project has been closed. So this is the iterative process. This is never going to end. Developing an acceptable project schedule is an iterative process. The schedule model is used to determine planned start and finish dates, which we have already created in the baseline for project activities and milestones based on available information, which is coming from all those places. Schedule development can require review and revision of duration estimate, resource estimate, schedule reserve to establish an approved project schedule that can serve as a baseline to track progress. So baseline is our target. Once we have a baseline approved version of the schedule, that is how we track the progress during the monitoring and control. Key steps include defining the project milestones, identifying and sequencing activities, and estimating duration, which is we have already studied in quite a bit of detail. Once the activity start and finish dates have been determined, it is common to have the project staff assigned to the activities review their assigned activities. When the people review their job, they feel differently. They feel the schedule says that this job can be done in 3 days, but this is impossible to do in 3 days. So we suggest, staff may suggest, the team may suggest that we will take 5 days to complete it. Now, this is a problem. This has to be put up with reasons as a change request to the higher authority as if it can be rebaselined. So, this is a reason for the change. The schedule is then analyzed and determined conflicts with logical relationship and if resource leveling is required, because if there is any change, if this activity moves from 3 days to 5 days, the resource availability and resource leveling would be required, right? That will shake everything in the schedule, right? All the dates will have to be shuffled accordingly before the schedule is approved and baseline. So we try to do all that before the baseline, but in case there is any change, we will have to redo everything. Revising and maintaining the project schedule model to sustain a realistic schedule continues throughout the duration of the project, as we have been talking about.
Yeah.
For more specific information regarding scheduling of how the things are done, we will refer to the practice standard for scheduling. But for the time being, I am quoting all the things from the guide of project management body of knowledge, right? Specifically the scheduling part of it.
Yeah.
Anyways, this is, I have already explained, these were the inputs. This is a bit of explanation about each one of these things. What are the project documents? You know them. What are the agreements? That is what we if we have to have some materials from our outside vendor, or
Yeah.
we have to have some outsourcing of the work. That all will be covered under the agreements. Enterprise environmental factors. If there is any change in government or industry standards or communication channels, such like things will impact your schedule. Within the organization process assets, if their procedures have changed, if their record has changed, if all that will, although this is helpful, but they can also affect our baseline. These are the various tools and techniques we have already talked about. We have the schedule network analysis, which we have done already. We understand what is it, how we create it, all that thing. But naturally, when you are finalizing the schedule, you may have to redo it, do some kind of analysis on that, how the network diagram works. Does it need to be tweaked or something? Critical path method, again, we have used it, and these are just the details about it. This is just an example of a critical path. On a very simple diagram, if this is the whole project with 4 activities, and they have got 2 paths to complete the project, as we discussed, the longer path will be your critical path. So in this case, the longer path is ACD, which takes 30 days, whereas ABD takes 25 days. So therefore, ACD is the critical path. Just like the template of how the things should look like, they have this template. They are not using what? They are using only everything else but 2 things we studied there. They were span and one more thing. 2 things are missing from here.
Yes.
One was span.
And
Yeah, they have added total float to it, which is,
free flow.
yeah, free float is not there.
Yeah.
Exactly. Early start, early finish, latest start, latest finish. And duration and total float. The span is the only thing, and naturally, if there is a free float.
Okay.
Critical chain method is an interesting method, but this is very different.
Mhm.
We need to understand that naturally. I do have another slide deck to explain what this critical chain method is, but this is
Mhm.
not the critical path method.
Mhm.
This is a different method and it's a very interesting method. Everybody
Yeah.
doesn't choose it, but if at all you are dealing with some very intricate and delicate project, I would
Mhm.
suggest that to assure that everything gets done in time, you should resort to this method. This brings a lot of control into
Mhm.
sensitive projects. This method allows the project team to place buffers on any project schedule path to account for limited resources and duration uncertainties.
Mhm.
Now, what happens is, although we have created a schedule, we have created a critical path, and everything is very fine,
Mhm.
but the problem is an activity which is 10 days long, how does we come to the conclusion that it will take 10 days? Naturally,
Mhm.
project manager is not allocating the durations. Durations are being suggested by the lowest level people who are actually going to do it. That is the best way. You should not estimate on your own. You should
Mhm.
involve and engage those people who are actually going to do it.
Mhm.
Otherwise, if you tell them you have 10 days, they will say it can't be done in 10 days, and then you
Mhm.
have to debate with them.
Mhm.
Anyways, the question is when people assign durations to their activities, they tend to keep a little margin for themselves. Do you agree with me?
Yes, sir.
If that you ask a person how much time do you need to take this job, maybe that activity could take 8 days. He say
Mhm.
it will take 10 days.
Mhm.
So he is without any reason, he is adding unnecessary duration to that,
Mhm.
and I don't know anything about it. And ultimately, my whole project will be inflated by at least 20%.
Mhm.
But that is not the end of the story. Actually, we have a deep hierarchy in our projects in predictive project management.
Mhm.
We have got people working under supervisors, supervisors working under another hierarchy.
Mhm.
Ultimately, there might be 3 or 4 levels of hierarchy until the
Mhm.
news come to the project manager. Now, just consider there are 3 levels under project manager. So, if every level starts putting their, you know, allowance into it,
Mhm.
for example, the supervisor has created a schedule for the team, that is a
Mhm.
team level thing, and he says that whole of this work will take 50 days. So that means all the, you know, all the durations of the
Mhm.
activities is not only added up, maybe they add up to 40 days.
Mhm.
So he has added his own 10 days to it. You understand my point?
Yes, sir.
Similarly, the next level will add another 1 or 2 days, and that
Mhm.
way it will be greatly impacted. The whole duration will not be just 20% extra, it may be
Mhm.
80 to 90% extra, right?
Mhm.
But because this duration has now been allocated to them, they will be content. For example, that activity has been given 10 days finally
Mhm.
in the baseline.
Mhm.
Although the person who actually can do it, he knows that this could have been done in 2 days. I said it will be done in 2 days. But ultimately, they are giving me 10 days to do it.
Mhm.
What is
Mhm.
going to be the psyche of that person? Will it will that person stand up and inform you, sir, this is wrong. This activity doesn't take 10 days.
Mhm.
This takes just 2 days. Will anyone do that?
This is pretty unlikely. some might, and some people might just go with the 10 days.
They would like, exactly. They will like to go with the 10 days.
Mhm.
And if you have to do a 2-day job in 10 days, how would you do it?
Kind of, I'm going to say, stretch it out to fit the 10 days.
Exactly. You will
So,
relax and the work will spread the time in the time available.
yeah.
The 2 days job will now be spread out to be 10 days job. This specific theory is probably called, I'm just
The
forgetting the name for it. Uh,
back in some.
it just will come to my mind.
Okay.
But you see, the
Mhm.
theory is work
Mhm.
spreads to fill the time available.
That's correct.
Whatever time you give to someone,
Mhm.
they will expand their work in that space.
Mhm.
If you give them more time, they further expand, right? So
Yes,
there is
sir.
a tendency to expanding the work in available workspace.
Mhm.
That means now this activity is 10 days long,
Mhm.
and this man has relaxed his 2-day activity to 10
Mhm.
days.
Mhm.
That means he has no margin.
Mhm.
In case anything
Mhm.
gets delayed within this activity, we will need additional day or days to
Mhm.
complete it.
Mhm.
So, practically speaking, the job which was 2 days long will not be possible to be done in 10 days. How to control it? To control it, this
Mhm.
method, critical chain method, is extremely useful. The undue durations they add to the actual
Mhm.
duration is
Mhm.
called padding.
Mhm.
Padding is a kind of a criminal offense in project
Mhm.
management. I am not against reserves.
Mhm.
Reserves are all right because they have a reason. There is a
Mhm.
calculation behind them. We know
Mhm.
how much is the reserve, how much is the
Mhm.
risk. But this padding is unnecessary and this is based on the whims of the workers.
Mhm. Mhm.
Therefore, this is not liked, this is not accepted as a practice.
Mhm.
But still, people in project management advocate
Mhm.
padding, right?
Mhm.
So padding, I must tell you, is not an official term. It is illegal term. It is a criminal offense in project
Mhm.
management. Padding
Mhm.
should not be done.
Mhm.
But unfortunately,
Mhm.
it is being done. And how to avoid it, I have to devise a mechanism.
Mhm.
Okay, let me give you an example. The
Okay.
activity was given 10 days. The person knew it could be done in 2 days.
Mhm.
You ask that person to do it in 8 days. Will he be able to do it?
No,
Once the duration has been allocated
yeah,
and
yes,
work has expanded to 10 days, now
yes.
if you tell him to even reduce 1 day, he is not
Change,
going to be very
yeah,
happy about it.
yeah,
He would say,
yes,
no, it
yes.
can't be done, give me extra day, and things like that.
Yeah, true.
So all the responsibility of delay is with you, and all the enjoyment of working slow is
Mm-hmm.
with the worker,
Mm-hmm.
right? I
Yes, sir.
hope you understand that scenario.
Absolutely, absolutely. Thank you.
Now, as a project manager, you could resort to critical chain method to put a check on that.
Mm-hmm.
I am not asking you to cut off the durations unnecessarily,
Mm-hmm.
but you must have some kind of statistical analysis
Mm-hmm.
specifically for your organization. What are the tendencies of padding in your organization? For example, you know that at least 50% padding is being done in my organization.
Mhm.
So I'm not asking you to slash everything by 50%,
Mhm.
but choose a figure. Say you cut everything down to 80%. Although the original durations allocated to them will not change, but what I'm doing is a 10-day activity is given only 8 days.
Mhm.
On the discretion of that person, 2 days have been deducted from there, but not deducted from the original duration.
Mhm.
They are considered as a buffer. This buffer is no more under the authority of the person doing the work. These 2 days have been allocated to the project manager's discretion.
Mhm.
So that means the worker would know I only have 8 days to do this job.
Mhm.
So the same theory works in reverse. Work will now shrink to fit the time available.
Correct.
So he would plan everything according to 8 days. He
Mhm.
will try his level best to do it in 8 days. Although we have 10 days, but
Mhm.
he has 8 days. He will try to do it in 8 days. And if he
Mhm.
can't do it, he will request the project manager. I have 2 days reserved for him, not reserve, buffer available
Mhm.
for that activity. I would not give it back to him. I will say, okay, I give you 2 more hours, complete it.
Mhm.
So I'll break it into very small portions and keep giving him those allowances until the job is finished. And trust me, the job will definitely be finished in less than 10 days. Do you agree with me?
Yes, sir.
Okay, now you understand this philosophy of critical chain. Let us
Mhm.
also talk about one more thing.
Okay.
Where should you apply this critical chain in the whole project? As you
Mhm.
understand from our
Mhm.
previous discussion on critical path,
Mhm.
we know that critical path is the most sensitive area.
Right.
This is the longest path, and
Mhm.
this is specifically to be protected. So, if a project manager ignores the non critical activities and only applies the critical chain method on to the critical path activities,
Mhm.
his job can be done. If the whole project is taking 60 days, and um, let's take another example. If it takes 100 days
Mhm.
and you have 20% of padding considered,
Mhm.
that means it now can be done in 80 days.
Mhm.
Got it?
Yes, sir.
And those 80 days must be cut from the critical path activities only. So, practically speaking, I am asking you to
Mhm.
attack the critical activities only, apply critical path on them, and
Mhm.
that means you will be allocating activity buffers to
Mhm.
all the critical activities,
Yes.
thus making it possible for the critical path to end in 80 days.
Mhm.
Moreover, what
Mhm.
about the other paths? If the other paths are less than 80, we don't need to do anything with them.
Mhm. Mhm.
But if, say, the second longest path is 90 days, then I need to cut 10 days out of it as well.
Mhm.
And I will apply the critical chain method on all those paths which
Mhm.
are kind of affecting my 80 days duration.
Mhm.
Now, you could apply different rules for different tracks,
Mhm.
but a simple method would be let us apply the same rule to the whole project. let us cut everything by 20%.
Mhm.
That way, no non-critical path will ever exceed the critical path,
Mhm.
right? Because they're
Yeah.
equally been reduced,
Mhm.
right? So we can
Yeah.
exercise our control over.
Mhm.
The, the, the buffer you create on the critical path is called the
Critical time.
project buffer because it is for
Mhm.
protecting the whole project. That is called
Mhm.
the project buffer. The buffer you create for non-critical paths, every non-critical path will have its own
Mhm.
buffer, which these buffers are called feeding buffers.
Mhm.
Feeding buffers. So you have a project buffer on the critical path. We on the all other paths we
Mhm.
have feeding buffer for each other path.
Mhm.
There is a third kind of a buffer, which is called a resource buffer. Let us look at another scenario. There is a
Mhm.
person who is supposed to be doing the 10 days activity, and after that,
Mhm.
he's going supposed to join the next activity,
Mhm.
which may not be on a critical path or may be on critical
Mhm.
path. Any one of these activities could be on critical path, but this person, after getting freed from this activity, will join another activity.
Mhm.
What if this person gets delayed in his first activity? It is going to impact the subsequent activity.
Yes.
So rather than making this person's availability back to back, I will put a buffer between these two activities. I will say once you get free from this activity and 2 days has passed, you, I mean, the next activity before the start of the next activity, 2 days
Mhm.
before the start of the next activity, you should definitely be there. You understand my point?
Yes, sir.
This is only applied to the critical resources. Those
Mhm.
resources we don't have a replacement for.
Mhm.
We need exactly the same person to be doing the next job. So I would ask him to be available this much time earlier before the start of the next activity. This is called our resource buffer.
Mhm.
This only applies independently to critical resources. Critical resource is not
Mhm.
a term related to critical path. These
Mhm.
are those resources which could affect delay in the project. They could happen anywhere. They
Mhm.
could be on critical path, they could be on non-critical path. But if
Mhm.
they could delay the project, uh, they are critical resources.
Mhm.
So critical sorry, uh, the resource buffers are
Mhm.
also created. So basically, what I have told you, there are three kinds of buffers: project buffer, feeding buffer for non-critical, and resource buffer for critical resources.
Mhm.
If you exercise this method
Mhm.
in whole of your life, ever, none of the projects will get delayed.
Cool.
I can assure you that. This is such a fantastic method because if you don't apply that, every project in this world gets delayed.
Mhm.
Agree?
Yes, sir.
Every project, even if if you manage it very closely, still it will be delayed by 1 day or 2 days. But normally it can be delayed enormously. 1 month delay, 2 months delay, 3 months delay, just because we are not applying critical chain method.
Mhm.
So this is not a mandatory method, but this is
Mhm.
a very effective method for managing your projects in time. This is how these buffers can look like. Say this is a critical path C, D, E, F.
Mhm.
So at the end, whatever time I have saved from activity C, D, E, and F, I'll sum it up, and that will be my project buffer. Because this is a critical path, project buffer is only deduced out of it. Then each other non-critical path, for example, AB is a non-critical path. So before it can join the critical path, I will put a feeding buffer as if this does not delay, this path does not delay the main path, the critical path. Similarly, I can put a feeding buffer here. And I have given you a example of a resource buffer. A resource buffer could be completely unrelated. It could be like, just a moment. It could be like this, a resource getting freed from A is going to go to E, right? So
Yes, sir.
so I wanted to put 2 days buffer here. So I will say 2 here. That means after completing A activity, within 2 days, it must be available for E activity. Or for that matter, before the start of E activity, 2 days earlier, this person must be available. That means between A and E activity, there is no relationship, but we are creating a resource relationship. We are making it mandatory that there must be at least 2 day advance notice for this person to be available for activity E. Now, I don't know when activity E is going to start. Maybe activity E is starting on the 15th day and activity A is ending on the 10th day. So, if at all, this person is going to be free for these 5 days and he is asking for a leave, I will give him leave for not more than 3 days, as if he can be assured to come back 2 days earlier than the start of activity E and can be available for doing that activity. This is a very common problem. A person who has gone on leave, he applies for extension. And if he was a critical resource, my activity E is going to be affected, and activity E is a critical activity, so my project is going to be affected. Got that? So
Yes, sir.
I will put a resource buffer like here. Sorry, like this. This is going to be my resource buffer of 2 days. I hope you completely understand what I am trying to explain to you.
Yes, sir. Yes, sir. Very
Wonderful.
thorough. Thank you.
Then we have got the resource optimization, and we have already studied. Then when we are adjusting the resources, we actually there are two ways. One is resource optimization, other is schedule compression, and we have talked about both of them. Resource optimization is leveling up the resources or smoothing the resources. These are the two ways of optimizing the resources. Let us see what do we mean by leveling and what do we mean by smoothing. Look at this diagram. The upper diagram is an example of resource leveling. Tom and Sue are required to do activity A for 8 hours. Simultaneously, Sue is also required on activity B, which is also 8 hours long. And this is one activity which only Sue is required. This is a specialized resource. Only she can do A and B. But the problem is A and B are happening in parallel. How can a person do two jobs at once? If at all, as we do in our projects, we put a person on two jobs simultaneously, and we think that he will be able to do both jobs in time. That is impossible. There is a capacity of every person. So basically, Sue will require 16 days, if not exactly 16 days, yeah, exactly 16 days to complete both jobs. Even if she is distributing the time 1 hour here, 1 hour there, 1 hour. So this is not going to end in either of the activities, will not end in less than 16 days. Whereas Tom will have to hang along with that because Tom is dedicatedly available for this job. Got it? So that means A and B activity, no matter if Tom is available or not, Tom is available for 8 hours. Just due to Sue, this activity is going to, activity A and B, both are going to stretch for 16 days, which is highly inefficient way. And we do not realize that. Moreover, Tom is required to be available after 8 hours on activity C. So this activity C will also be delayed. Got it? So what can we do about it? The simplest way of doing it is, naturally, both activities are going to take 16 days. So why should I not stagger A and B? Let us first concentrate and complete A activity. Tom can get free and go elsewhere. Sue can move to activity B and spend next 8 hours doing that. Once she is free from there, activity C can start and maybe Tom is required to do that job. So that way, your schedule will be pushed by the overlap period, and that would be 8 days extra. This is called resource leveling. Any questions about it?
So far, so good, sir. Thank you.
And another resource optimization technique, just a moment. I don't have a diagram for that. That is called resource smoothing. Now, here we knew exactly who is available at what time, and therefore we could do that. But let me give you another example. I may have to draw it because I don't think I have a diagram for that.
Okay.
Okay. For example, this is my project. This is my X and Y graph. Okay. I'll just put some random activities here. For example, this is one activity, this is another activity, this is another activity, this is another activity, and this is this activity, and this activity, and this activity, and ultimately this. So this is generally my schedule.
Okay.
On this, I require different resources. Let me write here. For example, I had, just for simplicity's sake, I have 3 resources. Resource A, resource B, and resource C. These are the only 3 people required for the whole project. Let us assume that. Just a moment. I may have to write it again. A, B, and C.
Yeah.
So let us say for activity 1, I need 2 A's, no B, and 1 C. Got it?
Yes, sir.
For whatever duration. For activity,
2.
let me give them some different names. Say J activity. Then I have got K activity. Here I need 0A, 3B, and 0C. Then for L activity, I need 3A, 2B, and 0C. For M activity, I need 2, 1, and 3. For N activity, I require 0, 0, and 5. For P activity, I need 0, 3, and 4. For Q activity, I need 3, 2, and 1. And the last one, R activity, is 1, 1, 1. Now let me erase this one and let me put it like from here to here. This is R. So for the clarity's sake, this is J, and I'm writing its duration here 5 days. And this is K, which is say again 5 days. L is 5 days. M is 7 days. N is going to be 6 days. This is P, which is say 6 days. And this is say Q. This is 12 days. And this one, R, is 7 days. This is it. So practically speaking, let me write these resources like this. This is 2A, 0, 0B, and 1C. Is it all right?
Yes.
So let us write 0, 3, 0 here. And let us write 3, 2, 0 here. And let us write 2, 1, 3. And here 0, 0, 5. And here 0, 3, 4. And Q is 3, 2, 1. And this is 1, comma 1, comma 1. Now,
Mm-hmm.
how many days are they? Let me just broadly calculate. 5 plus 5, 10. I'm just joining these, this with this with this. This is my critical path.
Mm-hmm.
And this with this. So
Mm-hmm.
my total duration is 5 plus 5, 10, plus 6, 16, plus 6, 22, plus
24,
7,
22,
29
23,
days.
29.
So this is basically 29
29 days.
days critical path.
29 days.
29, yeah.
Yeah.
Okay, let us see how many people do we require in A, how many A's we require every day. That is important. How many A's, how many B's, how many C's. So let
Okay.
me divide this whole thing into like, let me say,
Mm.
I wanted to change the color. Let us say this is 5 days,
Mm-hmm.
and this is 5 days, and
Yes.
this is 5 days, and this is 5 days, and this is 5 days,
Okay.
and this is 5 days, right? So this
Mm.
mark, this point is, let us say, if I start from 0, this is my 5 point.
5, yes. This is 10.
This is my 10. This is my 15.
Mm-hmm.
This is my 20.
20.
20. This is my 25. This is my 30. Now, let me put it here, right?
Yep.
Now, I want you to calculate
Mm.
for each day. Let me show you from 0 to 5. Let me break it
Mm.
down into further parts and show you that we will have, this is the end of first day, end of
Mm.
second day, end of third day, end of fourth day, and
Mm-hmm.
end of 5 day. That means this is my 1 day. This is my day 2.
Second day, yeah.
This is my day 3. This is my day 4.
Mm-hmm.
This is my day 5.
Yes.
Right? So that way, from 0 to 5, the 0, let me also write here for your clarification.
Mm-hmm.
This could be the point 1. This could be 2. This could be 3. This could be 4. I hope that is amply clear.
Yes, yes, that's good.
Now I am asking you, I'm now writing days.
Mm-hmm.
Days. So I will start here. So day, not day, that is going to be like between 0 and 1 is my day 1, right?
Yes.
So day 2, day 3, day 4, day 5,
Yes.
6, 7,
Okay.
8,
Eight.
9, sorry,
Mm-hmm. Yeah.
10,
Mm-hmm.
11, 12,
13,
14, and 15,
15,
16, 17,
mhm,
18, 19, 20, 21,
22.
8, and 29. Because my project is going to finish on 29,
Correct.
so I will only write here 29. 30th day is this one.
Mm-hmm.
This is the 30th day,
Yeah.
right? Okay. Now I have created this for you. Please tell me how many
Mm-hmm.
people you required, how many A's you require on day one. This is my day one.
Day one, two,
During this time.
yeah. So two,
Two,
uh, five.
2 plus 3, 5.
Yes.
So
Uh,
as far as A is concerned, I require 5. And how many B's do you require?
three,
No, no.
five.
Just talk about these two bars.
Oh, these two. Oh, these two. B is
Mhm.
B.
The center figure is B. The center figure.
Two.
2, very good.
Okay.
Just a moment. 2. And how many C's do you require on the first day?
Uh, one.
1. Very good.
One. One.
And this is going to, for day 1 to 5, this
Mm-hmm.
same pattern is going to be repeated,
Mm-hmm.
but it will change on day 6 because J activity will finish on day 5.
Yeah.
But this activity, sorry,
Activity.
let us say this is not 5 days.
Mm-hmm.
Let us say this activity is 7 days.
Mm.
So you see, this is continuing. So what is happening on day 6? Just look at this portion.
This six. L is still ongoing.
This is my 6th day.
Yeah.
K K and
L. No. No.
K and L.
Activity L. L.
K and L,
Yes.
yes.
Yeah. K and
So
L.
0 plus 3,
Three.
right. So here I will have, sorry, I'll have 3. And what about the next day? So B?
B. B zero.
No.
No wait.
B is this. Just look at these two bars. 3 middle one. Middle one is 2. 3 plus 2.
Five.
And what is C?
C zero.
0. Okay. And what about the next day? It is again going to be
Next
3.
day would be we have
Will be the same.
yes. Uh,
But
no,
on the 7th day, L activity will finish, right?
yeah, yeah.
Now, what I am talking about, I'm talking about this day.
Okay. So next day we
Now,
go
L activity has finished. So we have got K, M,
K,
and Q.
M, and R.
Q. So what is going to be X here?
Um, wait, A.
Uh,
Z-
what is
Zero, two, two, two.
th-
5.
5? Very good. 5. And B?
B, B, 3, 1, 1, 2, 6.
6. And C?
Um, 0, is it 1?
0, 3
3,
and
3.
0, 3 and 1.
Yeah, correct. Yes, yes.
So 3 and 1 is 4.
Oh, sorry, 4, yeah.
It is 4.
Mm-hmm.
Now, the portion, this is like this continued in this area. So
Mm-hmm.
this is going to be continued until this moment.
Mm-hmm.
After that, we have M, N, and Q
Correct.
at least for 7 plus 7, 14. At least for this much time. Actually, this much time.
Mm.
So for this much time, we will have 2 plus 3, 5, and
Yes.
1 plus 0 plus 2, 3,
2.
and 3 plus 5 plus 1,
Uh, plus
9. So
8,
this is
9.
going to go on like that,
Mm-hmm.
5, 3, and 9. But on this day, the very last day, it will be
Yeah,
only N and Q.
correct.
So this day, so it is going to be 0 plus 3, 3,
3,
0 plus 2, 2,
2.
and 5 plus 1, 6. And same thing is going to be repeated for the next day also.
Mm.
That is my 16th day.
Okay.
3, 2, and 6. And after that,
Mm-hmm.
I will have a new figure for P, the overlap of P and Q. P and Q
Correct.
during. So P and Q, 0 plus 3 is 3.
3,
3 plus 2 is
5.
very good, 5. And 4 plus 1 is.
Right, 5.
But this is going to continue for this much time. So my
Mm.
resource is going to be is consistent for this much time.
Mm-hmm.
And now this was 12 days. So that means this 10, bar, 19 days. Okay, whatever. There may be a little mistake because this bar should not be here. This should be,
Okay.
this bar should have been finished here like
Okay.
this. And it was the last day here. That means this
Okay.
is only P. So for this one day,
Mm-hmm.
this one day, only this one day,
Okay.
19th day, I mean, the 20th day, that would
Mm-hmm.
be 0, 3, and 4. And this is going to continue
Mm.
from this point to this point.
Mm-hmm.
And after that, my availability would be 1, 1, 1.
Mm.
And that is going to apply for the remaining period of the project
Correct.
from here to here.
Yep.
Right? You see,
Yes, sir.
this you could not have predicted
Mm-hmm.
that how many people you will be requiring on any one of the days until you have the net schedule completed,
Mm-hmm. Mm-hmm.
right? Once the
Mm.
schedule has been completed, the resources has been loaded, only then can you exactly calculate all living and non-living resources. And then you can talk about balancing the resources. Now let us see what is the maximum number of A resource required for the whole duration of the project. So it fluctuates between uh, A
Zero
fluctuates
and
between 1 to 5, B fluctuates between 1 to 6, and C fluctuates between 0 to 9.
0 to. Wait, I need to show.
This is the highest. This is the
Oh,
smallest,
oh, okay. Mm.
right? You can see
Yeah,
that.
yeah, yeah,
So
yeah.
if you were the project manager, how many A, B, and C will you hire?
Oh, okay.
The minimum and maximum requirement is there.
Maximum.
Maximum, okay. That means you are hiring on full capacity.
Yeah.
Uh, let me say, I may use different colors for them.
Mm.
Uh, the blue color, I
Mm-hmm.
am talking about, okay, uh, let me draw a bar on the other side, and let's make another scale
Mm-hmm.
and say this is 1. Just a moment. Uh, maximum is 9. 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? If
Mm-hmm.
I draw A, let us say A is a blue color, so
Yep.
it would be maximum demand would be 5. Maximum demand could be 5 throughout. That's what you are saying.
Yes. Yes.
And what about B? It is maximum
6.
demand is 6.
Yes, sir.
So let me use another color for that, say green. So this would be like this.
Yes.
And what is the maximum demand for C is 9.
9. Mm.
So let us say it is this, it is like this.
Mm-hmm.
If you do that,
Yeah.
if you do that, you are probably doing what you are doing in your projects. But this is the most inefficient use
Mm-hmm.
of resources
Mm.
because the days A will not be required,
Mm.
you will be paying him unnecessarily.
Correct.
You are going to pay all your staff for the whole duration of the project. Whereas, let us see how much do they get used.
Mm-hmm.
Okay. Let us say A, let me only draw the A bars.
Mm-hmm.
A on the first day is 5. This is it.
Correct.
And it is going to be same for first 5 days.
5 days. Yes.
This is the requirement, meaning
Mm.
For the first 5 days, I have no problem.
Yeah.
Then my requirement is 3. For how many days? For 2 days.
For the out of three.
And then it again rises to 5
Yeah.
until this moment.
Mm,
Then it again declines to 3 for this period. And then there is no requirement. And then
mhm,
there is a requirement for only one person for
mhm.
this duration. Can you tell me
Yeah.
why are you paying this person for this period?
No, it would be more efficient to pay the person when it's being used.
Exactly.
Mm.
That means um, this is not fine that
Yeah,
there are blocks of unavailability,
correct.
right?
Mm.
So somehow, rather than paying 5 people, I may
Mhm,
decide to pay 4 people or 3 people.
mhm,
That way, for example, I decide to level the resource
mhm,
at 3. Sorry. If I level the resource at 3, it could be like this.
yeah.
That means I will only use not more than 3 people
Mhm,
at any one point in time.
yeah.
Even if I require more, that
Yeah.
means I am ready to expand these activities to a couple of days. Maybe it will
Mm.
be inflated. My whole schedule will be inflated from 29 to 31 days,
Mm.
right?
Yeah.
But it will be judicious use of resources, more judicious use of
Mhm,
resources.
mhm,
So this is the requirement only for couple of days that I need 5 people. So I
mhm,
cut
mhm.
that requirement. This is called resource leveling. I have
Correct.
leveled these resources,
Mhm,
thus causing my critical path a little damage.
mhm,
I have increased the duration, but at what cost? I have been paying them unnecessarily for such a huge period. I have saved
mhm,
all this money, this money, this money, this money. I have saved it all.
mhm, mhm,
I could not save this much. You can't do anything about it. You can't save this money,
mhm,
right? But if you want to level it on 2, probably you can save some of that as well. This is called resource leveling, readjusting the distribution of your resources uh, to save money.
mhm,
Got it? This is
mhm,
called resource leveling. Sorry,
yeah.
resource
Mhm,
smoothing.
mhm, mhm.
Did you get the concept?
Sorry.
If you want to take a screenshot of this could be
Okay.
used.
Um,
When you are done, let me know.
okay. It's done, sir. Thank you. Mm.
So do you completely understand the concept of this thing?
Yes, sir. Okay.
Okay. Okay. So this is resource leveling and resource
Mhm,
that
mhm,
thing. Then
mhm,
we do a lot of analysis, data analysis.
mhm,
And as I described to you, what if analysis, what if scenarios you create, what if this happens, what should I do, things like
mhm,
that. You could simulate. These are normally to discover the risky situations and trying to
mhm,
explore inside out what can happen to you, right? This is your
Mhm.
intelligence and creativity by which you manage so many things, right? So this is
Yeah.
now how do you do the simulations? This is an example of a
Mhm.
Monte Carlo simulation. Here, the probability distributions are shown. You see, uh, in, in 3-point estimate, remember that I talked about that 3-point estimate. I told you 80% of the people's
Mhm.
opinion lies here, and 20% of the opinion generally lies on the positive or negative side. I mean,
Mhm.
on the two extremes.
Yeah.
So normally we bother about this black area.
Mm.
This is 80-20 rule. 80% of the problem are caused by 20% of the reasons, right? So
Mhm.
if I can cater for these 80% and also to some extent I can cater for that 10% on this end and 10% on this end, I could create a graph like this. You can see that.
Mhm.
This S curve actually helps me predict when can this project finish. For example,
Mhm.
the probability of this project finishing on various dates is written here. The latest it can finish on 14th of June.
Mhm.
Earliest it can finish on 5th of May. But your schedule says what I don't know, what you have calculated. But
Mhm.
this is the data of the 3-point estimate
Mhm.
put into a simulation, and it tells me, for example, let us say you had estimated that
Mhm.
this job will be completed by, say, 15th of May.
Mhm.
Your schedule says 15th of May. What is the probability of completing this job on 15th of May? Just look at this bar and
80%.
draw a
Mhm.
straight line till here. Touch this one. There is this is on the right hand side. There is a
Yeah.
scale of percentage of possibility.
Mhm.
There is
Mhm.
a 90% possibility you would be
Mhm.
able to complete this project on 15 May. What is the 100% possibility? 100%
100.
possibility is you will definitely be able to complete it by 14th of June. What is the possibility of completing it earlier than that? Right? So this cannot be created by you. You have to use computer simulations. There are software for risk analysis, for statistical analysis. You can use those and create these kinds of probability distribution and can set your target milestones and try to decide. And moreover, you can even show it to your boss that this is the statistical analysis. And based on that, although we calculated the project will finish on 15th of May, but this is practically not possible. It is only 90% possible that we can finish on 15th of May. But if you want to be more sure about it, you want to consider the uh, all the possibilities which could happen to us, the risk. That means we should set the date for something more than 15th May. 20th is more safer. 25th is even more safer. The safest is 14th of June. Naturally, I don't want to be overprotective. I have to take some risk. So, for example, I take risk up to 30th of May. 30th of May gives me 95% of probability. That is good enough for me. I'm ready to take 5% risk. Got it? If you don't take any risk, your project will finish on 14th of June. If you go according to your plan, you carry 90% risk of not able to complete it on time. But if you choose 30th of May, I mean, you add 15 days to your schedule, your chances of, uh, you know, achieving that target are increased by 5%. Although you are not on 100%, but you are ready to take the 5% risk. That is why 30th May could be a good bet. Are you with me on that? Or is it confusing? Can't hear you. Your mic is not
Yes,
on.
I hear you. I'm here. I'm here. Yeah,
Okay.
it's all good. Thank you.
Okay.
Yeah, yeah.
So you understand the idea. I don't ask you to do all this all by yourself. This is just an introduction into this
Mm,
world of statistics, simulations, and all. This
mm,
is a big
mm,
subject, right? But I just wanted to introduce you how this is done. Then you already have the concept of leads and lags.
mm-hmm.
Schedule compression. I suppose
Awesome.
I don't need to talk more about crashing and fast tracking.
Mm-hmm.
You remember that?
Yeah, yes, sir. Sure.
You see, this is an example where this is your normal schedule. These are the
Yes.
three people who are actually put on separate, there are three separate people.
Mm-hmm.
This job take 5 days, this job take 5 days, this job take 5 days. If we can somehow overlap these jobs,
Mm-hmm. Mm-hmm.
means I pull this middle activity 2 days earlier and
Mm-hmm.
this activity again 2 days earlier, we will
Mm-hmm.
end up doing all the work in 11 days with a overlap
Mm-hmm.
of 2 days in every activity. Uh,
Yeah.
I can do this job in 11 days rather than 15 days. If it is a matter of just squeezing the schedule, right?
Yes, sir.
Crashing means that we want
Mm-hmm.
to put more resources on each activity, thus
Mm-hmm.
be able to complete it earlier. But naturally, it is going to cost you much more. Although you can reduce your schedule from 15 days to 10 days, but it may double or triple your cost.
Mm-hmm.
If you want to take that, this is only done in emergencies. Fast tracking
Mm-hmm.
is the normal behavior you adopt during fixing your projects.
Mm-hmm.
But if you are stuck at the last moment and you have to deliver tomorrow, how can you do
Mm-hmm.
it? You can then do crashing. Crashing is never your first option. Your first option is as much parallelism you can increase in your project by doing the fast tracking. That would be the ideal solution.
Mm-hmm.
Although when you are overlapping activities, you are increasing the risk. But there is no upfront cost because whatever money I had to pay on day 6 and day 7, I am now paying alongside day 4 and day 5. I don't spend anything extra, only I'm spending it earlier.
Mm-hmm.
But in the case of crashing, I am spending enormous amounts of money to get the job done much earlier. So this is fast tracking and this is crashing. PMIS, I have already introduced you. This is
Mm-hmm.
an automated system. It could be MS uh, project, it could be Primavera, it could be even more refined uh, automation software like workflow mechanism of the whole project.
Mm-hmm.
That could be more ideal. Agile release planning only applies to agile projects. In agile project, we don't plan the whole project upfront in detail. But we do a broad distribution of the agile project because we don't know all the details. So we can just bifurcate it on the initial understanding.
Mm-hmm.
Just like we create phases in a predictive project, here we don't call them phases. Phases is the work, packages of work, right? I mean,
Mm-hmm.
in one phase, you have to deliver something.
Mm-hmm.
So you have to do a lot of work.
Yeah.
Here we are not concerned about what we have to do. Here we are concerned about what we have to deliver.
Okay.
So these are release points defined in the project. Like they could not may not be equidistant. They may be just like phases, but these are the points. Point number one, release one, I have to deliver this. Release two, I have to deliver this. So during your project, just like phases, I can break it down into a number
Mhm.
of releases. Under those releases, we will run our agile iterations of
Mhm.
very small sizes, right? Those could be 2 weeks or 3 weeks long each. But you decide what is going to be size of your iteration. Size
Mhm.
of iteration cannot change during an agile project. If you fixed it to wait 2 weeks, you will have 2 weeks iteration. If
Mhm.
your first release was 3 months long, so that means you will have approximately 6 iterations to complete 3 months.
Mhm.
So that is how we plan in our agile release planning, but
Mhm.
I'm not going into the detail of that.
Yeah.
This is generally the picture. These are the releases. You may have,
Mm.
say, 3 releases. Each release may have its own set of iterations, iteration one, two, three, whatever. Two will have similarly, but it is not necessary that every release will have equal number of iterations. No, they
Mm.
can have different number of iterations. Every iteration will have a couple of features to be accomplished. Those features could be represented by user stories. Our user story can represent a single feature, or more than one user stories can represent a single feature. For example, feature A could be represented by two user stories. Feature B is represented by a single user story. So, meaning if the feature is difficult to accomplish in 2 weeks, then we will give it 4 weeks and we will divide it into two user stories.
Mhm.
Otherwise, generally the feature size should be small enough to fit into one iteration. Moreover, once we start doing each user story in each iteration, we break these user stories down into tasks and then we plan them. So basically, we are planning only one iteration at a time. Only 2 weeks planning, not the
Mhm.
whole project planning. Only 2 weeks planning. You accomplish that, you deliver that, and then you go to the next iteration
Next
and
one.
next iteration. This is how we work here.
Mm.
Outputs, as we have already discussed, these are all the
Mhm.
outputs. Baseline, your schedule, which includes the bar charts,
Mhm.
milestone charts, network diagrams, etc.
Mhm.
All those documentation.
Mhm.
And project schedule is something like that,
Mhm.
right? It could be represented in many forms. It could be in a
Mhm.
milestone form. It could be in a bar chart form, or it could be in a detailed form, right? Once
Mm.
you put data into MS Project, it could be represented. You could show it in many formats.
Mm.
So basically, these are all the various instances of the schedule. Then all that data of the schedule is secured into the database of the computer,
Mhm.
right? All the bars are actually being resulted out of the data. So data is more important for us. Project calendars, who is available at what time?
Mhm.
Change request, as I described, whenever you want to amend the baseline,
Yeah,
you have
baseline.
to move a change request. And thus, as resultantly, your project management plan can be updated and your documents, project documents, can also be
Mhm.
updated. So this is the end of developed schedule.
Mhm.
Was it useful?
Yes, sir. Very useful.
Very
So
nice.
yeah.
So
Mm.
now is the time we can take a break
Okay.
for, I need about 25 minutes. Is it all right?
Mhm. Okay. Okay. Thank you,
Uh,
sir.
Okay, see you after 25 minutes then.
No problem. Thank you very much.
Thank you.
Mhm.
So control schedule is a process of monitoring the status of project activities to update project progress and manage changes to the schedule baseline. Basically, the key benefit coming out of it is that we do have the schedule baseline maintained throughout the life of the project. This is the job of control schedule to maintain the schedule baseline. Now, maintaining the schedule baseline means two things. Number one, working exactly according to the schedule. Number two, if there are any changes, those change requests to be moved and in new baseline be created, and then for future you will start following the new updated baseline.
Mhm.
That's how control works. And this process, just like planning, is continuous in nature. This can be performed throughout until the end of the project.
Mhm.
This process could be viewed in this chart like inputs. We have got project management plan where we within the project management plan, the most important document for us is the schedule management plan and
Mhm.
the schedule baseline which we had created. Then the scope baseline also plays its role because scope
Mhm.
baseline was the cause of developing the schedule, and therefore
Correct.
scope baseline and schedule baseline can be monitored simultaneously.
Mhm.
Performance measurement baseline means that it also includes the cost baseline in it. Right?
Mhm.
Performance measurement baseline is the collective baseline of scope, schedule, and cost.
Mhm.
Project documents we require for the control purposes, lessons learned registers are required. Project calendars, which we created earlier, they are required. Project schedule, the models we created earlier, we require them. Resource calendars are required. Scheduling data, which I said it is a database in which they are lying, so we need to have access to that.
Mhm.
Work performance data as the work is being executed during the execution. What is the data generation based on that work performance, whatever has
Mhm.
happened, right? So we have to have this data to analyze and to convert it into something more analytical and more usable. We have organizational process assets. Then for tools and techniques, we have got a lot many analysis to do, but most of those analyses are the very same as we have learned before.
Mhm.
For example, we have got earned value analysis. Although this might be new to you, but earned
Mhm.
value analysis is something where we monitor the project based on schedule and cost together. And
Mhm.
interestingly, this one method you can measure the progress of scope of schedule and cost simultaneously, and to
Mhm.
some extent, you can have an idea of the scope progress as well. That means
Mhm.
all the three baselines can be monitored through this earned value analysis. Then we
Mhm.
have got for agile project, we have got
Mhm.
iteration burn down chart, which tells us how much was the work in an iteration and how much has already been done.
Mhm.
That means always shows us the remaining work during the iteration, because I told you iteration may be 2 weeks long. So when you started, you had a load of say 200 story points, and by the end of first day, you have 180 story points left, and that is how you measure it. So every day
Mhm.
you keep measure the progress, but this is a opposite chart. This is not a chart moving upward. This is a chart moving downward,
Mhm.
because it starts with the total work to be done and it shows us remaining work at every day. So it keeps going downwards. It starts with the highest point and keeps going downwards until the last day, which where we expect it to be zero. Then critical path method we already understand. Anyways, the performance reviews are there, trend analysis, variance analysis, what if scenario analysis. We have talked about all of them already. Critical path method also, we had a very deliberate discussion on that. Project
Mhm.
management information system will also be tool here because this is where we archive our data in a
Mhm.
computer system. And resource optimization, resource leveling, using leads and lags,
Mhm.
schedule compression, all of these techniques will be used for recalculation of the whole schedule and rebaselining purposes.
Mhm.
As a result of the analysis of the work performance data, after we analyze it here through these data analysis tools, we convert it into intelligent form, which is called work performance information. Previously, it was numbers. Now we have converted those numbers into intelligent data,
Mhm.
right? So
Mhm.
this intelligent data is called information, work
Mhm.
performance information. So we received work performance data, we converted into work performance information. Then we create some other analytics based on the earned value and other tools we are using here, trend analysis, variance analysis. We can forecast the schedule that in the current situation, what is the expected date of finish for this project when all the work can be done.
Mhm.
If there are any change requests, they can be launched from here. Project management plans can be updated here, which could include the schedule management plan, the schedule baseline, cost baseline, performance measurement baseline, all of the four things we talked about there, they were in the input. Now, when the new change request is moved and plans are being updated, all of them can be updated. Similarly, the project documentation, which could be updated, could be the assumptions log. New assumptions could come up, basis of estimate, because we have used that basis to calculate everything.
Mhm.
Lessons learned register can be updated with what we have learned. Project schedule can be updated. I mean, the instances of the schedule and source calendars can be updated. Risk registers can be updated, and schedule data can be updated. All of those things can be updated. So here is the control. Project management plan. We are getting these four things, and when we are done with it, we are updating these same four things. Project documents, we receive all of these things, lesson learned register, calendars, project schedule, resource calendars, and schedule data. And once we are done with control schedule, we are submitting them back along with some new things like assumptions logs is new, basis of estimate is new, lesson learned is the same, project schedule is the same, yeah, and resource calendar is the same, risk registers is a new thing, and schedule data. Anyways, these all are updated. What else? Direct and managed project work, that is where the execution is happening. The
Mhm.
data being generated is called work performance data, the raw data. When we transform it into something more intelligent, it becomes a work performance information which we submit to the integration process, monitor
Mhm.
and control project work, which has the overall responsibility of monitoring the whole project from all perspectives. So I am giving him the scheduling perspective. My work performance information represents the schedule. Similarly, there are other knowledge areas and other controls. There are every knowledge area, almost 10 different controls exist, and they generate their own work performance information.
Mhm.
That is unified here, and based on that, they could create their further plans and consolidated reports, right? And if there is a change request, those change requests are forwarded to perform integrated change control, which is another
Mhm.
integration process. Now, there are two integration processes with which we are interacting here. One is responsible for monitoring and control, other is responsible for change requests. So change requests are being sent to integrated change control that will be presented in front of the change control board. They will approve or reject it and whatever. But the work performance, the analysis is happening here, and it will result in the work performance report. So we started with work performance data coming here. We analyzed that and we converted it into work performance information, sent it to
Mhm.
monitor and control project work. It received other work performance information from other controls, and ultimately, all consolidated, it could be converted into a work performance report. So the journey is work performance data to work performance information to work performance report. It's the overall report. So I don't need to say anything about all these things. They are the same. As far as the control schedule is concerned, it is a conventional approach. Updating the schedule model requires knowing the actual performance to date. Like, as of today, what is the actual progress of the project? That is what is actual performance to date. Any change to the schedule baseline, if anything is not according to what the baseline was, meaning we are falling short of it or falling ahead of it, that means there is a change, right? Does it affect anything, schedule, scope, or cost? If it doesn't, we don't need a change. But if there is a considerable change which could impact our scope, time, or cost, our three baselines, so in that case, we may have to move a change request, which can be approved through the perform integrated change control process. Control schedule as a component of perform integrated change control, which is a overall change control mechanism. Is concerned with determining the current status of the project schedule, influencing the factors that create the schedule changes, reconsidering necessary schedule reserves, if at all we have to use the reserves in case of risk or something, determining if the project schedule has changed, meaning if the schedule has changed, it has to be updated, managing the actual changes as they occur. For agile approach, the things are slightly different because in agile, the way of working is quite not similar to the predictive project. Here we have got, as we are working in small iterations of 2 weeks, so our total work is centered around that. Determining the current state of the project schedule by comparing the total amount of work delivered and accepted against the estimate of work completed for elapsed time cycle. Naturally, we also have a mechanism of taking the progress, how much have we delivered, how much we have the elapsed time cycle for. Conducting retrospective, this is a continuous exercise. After every iteration, we do a heads down approach. We do a retrospective meeting, which is like a lesson learned meeting. We discuss what we did right, what we did wrong, how can we improve it in the next iteration. But you see, this is very different in a predictive project. This happens only once at the end of the project. Whereas what we are doing here in Agile is after the end of every iteration, we conduct a retrospective, learn from that, and apply those lessons immediately to the next iteration. Whereas in a predictive project, when the project ends, we do the retrospective or the lesson learned exercise, and that is of absolutely no use to the current project, but may be useful for future projects. Right? But here we are fully making use of all what we are learning. In this iteration, we learned a lesson, and we are just using it in the next iteration, and that way we are capable of continuously improving. Reprioritizing the remaining work plan. That means after every 2 weeks, when we get back on the board, we again reprioritize everything. We don't need to have a change request mechanism. We don't even have to make a change request because the customer is free to add any requirement at any time. We don't freeze requirements ever. Therefore, we don't need a change request. So during one iteration, whatever we were working, we deliver that, get back, and see what all are the requirements, the new and old requirement, and what are the most high priority items. We reprioritize that work and pick the most important work from the customer point of view. So highest value we deliver by selecting the highest priority items. And we keep delivering after every 2 weeks. It's a continuous process. So after we come back, we reprioritize whatever lying in the backlog. Backlog means where the requirements are lying, and that backlog is sorted, reprioritized, and then we pick up the highest priority item and start working on them. Determining the rate at which the deliverables are produced, validated, and accepted. That is called velocity. What
Mhm.
is our velocity, our team velocity? How much work can we handle in the given time per iteration? Agreed upon work cycle duration is typically maybe 2 weeks is ideal, 3 weeks possible, 4 weeks are also possible. Determining that the project schedule has changed. I mean, we are not much tied to the project schedule as such because there is no project schedule for the whole project, but generally we have an idea of the roadmap that is according to the releases. So we can have a picture what have we delivered and what is the progress, but generally speaking, we are more concerned about the progress at the iteration level. Managing the actual changes as they occur without any process of change request. There is no mechanism of change request in Agile, but change is open and change is free. Customer is also allowed to make any changes. They can add new requirement, they can subtract old requirement, they can do anything. We don't stop them. We rather welcome them that this is most welcome. You can do anything you want. We will do it. That is our promise. When work is being contracted, regular and milestone status updates from the contractors and suppliers are a means of ensuring the work is progressing as agreed upon to ensure the schedule is under control. Scheduled status reviews and walkthroughs should be done to ensure the contractor reports are accurate and complete. That is how we deal with our contractors, subcontractors, or whatever you want to call them, because some of the tasks may not be done by the team themselves, and that has to be outsourced. So in that case, we have to deal with our contractors or suppliers in such a manner that first of all, they should be following the same rules that we are following of agile. Secondly, we must have certain agreed upon walkthroughs and all how we would see and check if the things are right. Okay. Other inputs could be the project management plan, which could include any one of these things, all of these things. Project documents, as we discussed, all of these things. Work performance data, that is the data coming from execution in raw format. It could include what was the actual duration, what is the remaining duration, what is the physical person complete, the raw data as it comes. Organizational process assets, we could have used many policies, procedures, and all schedule control tools and monitoring and reporting methods, etc. They could have been used for the organization process asset. We in tools and techniques, like I said, we have got a lot many things. Data analysis, we have earned value, we have iteration burn down for agile, performance reviews, trend analysis, variance analysis, what if scenario analysis. We talk about these, and then we have critical path. We have already discussed in quite a bit of detail. I think the remaining things are not much worth here, but these things are important, so we need to talk about these. Data analysis could be done in two ways. One is earned value management, earned value analysis, which is usually done on a predictive project, but there are ways and means for doing earned value on even the agile projects, right? But primarily earned value is designed around a predictive project. Then we have got iteration breakdown. This is a technique which can be used only in agile projects, and this is very common technique where we check the progress of an agile iteration by seeing what is left to be done at any point in time. We just talk about the remaining work. We don't talk about how much has been done. We talk about how much is remaining to be done. This is how a burn down chart may look like. Like, uh, this black line, straight line, sorry, I mean, yeah, this dotted line is our expected line, how the work will be. This shows this is the total work, and this is I'm sorry, uh, the ideal remaining work is this one, the straight line. Right? The total workload was around to 250, and we had 10 days, working days to do it. So equally divided into 10 days, it could come down just like a straight line. Okay, what is actually happening? On the first day when we started, we had 250 units of work, and
Mm-hmm.
second, by the end of the first day, we were supposed to have been somewhere around 200 and say 30 story points, but we
Mm-hmm.
actually were at 248 story points,
Mm-hmm.
meaning we did
Mm-hmm.
less work than expected.
Correct.
That way, keep plotting this progress downwards
Mm-hmm.
in a burn down chart.
Mm-hmm.
And take an average. This dotted line is an average which could predict into a direction when this iteration can be complete. But you see, iteration size cannot be changed,
Mm-hmm.
right? So that means that when the working days are over, the the work will be considered complete. I mean, if I draw a line,
Mm-hmm.
this is my end date. So
Mm-hmm.
whatever I have achieved on this date, that will be the iteration will close. What happens to the ongoing work or the remaining work which is not yet started, that all is considered incomplete and is submitted back to the product backlog.
Mm-hmm.
In the next iteration, we may address it. But right now, we have only these days available, and we could do as much as we can. During this iteration, we could have, taken measures to speed it up. Like, looking at this dotted line, we will try to bring this dotted line as close to the this ending point zero. So this is our monitoring during the iteration.
Mm-hmm.
Otherwise, this doesn't mean anything. If the dotted line is going beyond the actual end date, then it is not something which is we can't extend our iteration. Iteration size cannot be changed. So forecasted remaining work actually will be shifted back to the product
Mm-hmm.
backlog, and
Yeah.
maybe it would be addressed in the next iteration.
Yes, yeah.
Okay, then we have got data analysis, performance
Mm-hmm.
reviews are conducted, trend analysis. Let me show you if it is there. No, it is not there. Trend analysis, you might have seen, it is kind of a
Mm-hmm.
just like this was a trend, this dotted line was a trend.
Mm-hmm.
And even in a predictive project, we do have this kind of prediction mechanisms, forecasting mechanism. So this is called trend analysis. Examines the project performance over time to determine whether performance is improving or deteriorating. So the dotted line tells us we are far behind or we are ahead. Graphic analysis techniques are valuable for understanding performance to date and for comparing to future performance goals in the form of completion dates. We also have a variance analysis. What is a variance analysis? What is kind of how much have we varied from our actual schedule? Are we ahead of schedule? Are we behind the schedule? How far behind or how far ahead we are, and why is the reason why we are doing behaving like that? So this is called the variance analysis. A what if scenario is for the risk management purposes. What if this risk occurs? What would be my next steps? Or how could I avoid this? If there is a risk, number one step is we will try to avoid the risk, respond to the risk. So we must have some reserve to deal with that kind of thing. But if a risk occurs, that is when the damage has been done. So then we are more concerned about dealing with the damage. That is not the subject of risk management as such. That is called issue management. But the subject of risk management deals up to the moment the risk occurs. After the risk occurs, uh, we are that is someone else's responsibility to manage the issue. That becomes an issue. Anyways, this was one thing. Critical path method, we have already discussed that. Project management information system, you are very well aware about. Resource optimization, we discussed lead and lag, schedule compression, These are the total outputs of your control schedule process. Naturally, it looks very similar to what there was in the monitoring, but here we have got kind of slightly different outputs coming out for the schedule management plan updates and document updates according to the role of the control. Work performance information I have introduced you. This is the analyzed result of the work performance data coming from schedule. All such different work performance information from various knowledge areas, various controls, will be compiled later by integration in form of a work performance report. Schedule forecast, you should be able to predict for a predictive project, you must be able to predict if it is not ending on the expected date, when will it end? So that is called schedule forecast, meaning it will end 10 days later, 5 days later, 3 days later, or earlier maybe. So whatever, that is called the schedule forecast. Change request, as you understand, if there is a change, and what is the reason of change? Always the reason of change could be one of the three. Does it affect scope or schedule or cost baseline? Any one of these three baselines are, if they are interrupted by any change, then that change is a genuine change. Otherwise, if it is not doesn't impact scope, time, and cost, then we don't deal it as a change at all. We don't require a permission from the higher authorities to approve this change request, because that means if I cannot impact the scope, time, and cost, I, as a project manager, am fully authorized to take any steps. But if there is an impact on scope, time, or cost, then it has to be moved through a change request. Approval will have to be sought, all the documents be updated, and then we can start acting upon that. These are the various updates to the schedule management plan, documents, and that's ends are the schedule portion from the PMBOK guide thing. We are going to have take a break, and we can then start off more deeper subjects like the standard for the schedule management specifically, which has got more details. So although the technical things all you have learned so far, but the in-depth knowledge about certain things which has not been available earlier in our discussion, I would be exploring those areas with you. So we can have a break, say about 15 minutes. Will that be fine? Okay.
Thank you, sir.
Most welcome. See you after 15 minutes. Right. So we continue, and I'll take you to critical chain project management. I have given you quite a bit of idea how it works. Basically, what we are trying to do is, I'll give you the concept. I'll not go into a lot many things because the basic concept you already have. So maybe minute details are not really very important for you. So first of all, what makes a project? There must be one single endpoint. You agree with that?
Yes, sir.
At least two tasks linked by dependency. This is also a fact that if there is a dependency between two activities, there is a task which is successor and there is a task which is predecessor. Significant inherent unpredictability in how long the task will take. This we have discussed that we are not really sure how long an activity can take. It could be due
Mm.
to padding, it could be due
Mhm.
to risk or bad
Mm.
luck.
Mm.
But things may not happen as we plan. How do you adjust for that? Do you know how many projects finish on time and within budget?
No lot.
Very few, very few.
Ah,
Meaning,
okay.
during the life of the project, they change their schedule so many times, it is not possible to accomplish the very first schedule. So, schedule does change. Even the cost of the project also varies a lot.
Mm.
In top and middle level management's opinion, it's always somebody else's fault. Blame it on
Okay.
someone. No, like a good project manager, you won't do that.
Mm.
You are tuned to take the responsibility of whatever happen under the project. You can't point
Mm.
fingers towards others. You
Mhm.
are responsible to fix it. You are responsible to get the things done. So if
Mhm.
job is not done,
Mhm.
is not well done, it is all your fault. You can't
Mhm.
blame it on this person or that person.
Right.
The lower the level of the person, the more the fingers point internally rather than externally. We don't blame our bosses, we blame our subordinates, which is bad.
Mhm.
People complained about lack of sufficient supervision of the vendors, but at the same time, they also complain that they are so overloaded they barely have time to deal with fires.
Mhm.
Meaning, you are dealing with a project and you have got your own team, you have got two subcontractors working for you, and
Mhm.
because you can't pay enough time to monitoring of the subcontractors, so you always have a reason. I am too busy, right? That is again
Mhm.
not a good reason. It is under your responsibility. You have to control everything.
Okay.
You have to take the charge of everything.
Mhm.
Why isn't the uncertainty properly factored into the original estimation? So, question arises, why did we not consider what is happening to us now?
Mhm.
Why are companies so immersed in their mentality of saving money that they forget that the project is not to save money but to make money?
Mhm.
Very important point, right? We are so miser when we are dealing with a project. We are cutting cost at every junction,
Mhm.
which may not be really suitable for the project because it may affect the profitability of the project
Mhm.
ultimately. If you don't put in good inputs, you can't get good outputs. So it is not about just saving the money, it's about making the profits. Do you know how much time it takes to develop a new airplane from concept to an operational weapon system? You
10
understand,
years? Huh?
years or maybe sometimes decades.
Ah.
It is a very complex ordeal, right? But
Mhm.
the question is, it does take more than 10 years. The U-2 bomber was developed in a surprisingly short time.
Mm.
8 months after start, this airplane was already flying over Russia taking
Wow.
pictures. How
Wow.
could that be possible? If a normal over airplane takes 10 years,
Mhm.
how could someone do that in 8 months? Can
Yeah.
you do that with your projects?
Possibly, if you can build a plane in a short period of time, it's so
Right.
complicated in equipment. So yeah,
Okay.
technically, yeah.
I think if it was the total time duration, the total schedule was 10 years,
Mm.
what maximum you can do is to shrink it to 8 or 9 years.
Mm.
Shrinking it down to 8 months, less than a year, is
Yes,
almost an impossibility.
correct.
Having said that, trust me, there is no impossibility in this world. This
Mhm.
is just a
Mhm.
barrier of our mind.
Mhm.
You just have to reduce the barrier and see things can happen. For example, uh, there was a new CEO in a mobile company. the mobile manufacturers, he took charge and
Mhm.
he called all the necessary people and
Mhm.
asked them that I have heard of a problem that the customized mobile phones from order to delivery takes more than a year.
Mm.
Why is it taking so much time? Go back and come back with the answer. So the
Okay.
team went back and they thought about it, they calculated everything. They said, well, it does take 1 year and it has to take 1 year because
Mhm.
orders are received and this much time is spent in this thing and that thing. He said, okay, can you reduce this time? Come up with suggestions. In the next meeting, uh,
Mhm.
what do you think the suggestions could have been? How much they could come up with? Well, mostly somebody would come up and say 10 months. Somebody will come up and say 9 months,
Mhm.
right? That is the optimum you could achieve. He said, no, I don't like it. Open up your minds. You can
Mhm.
do better. They again got back. They again thought about it. They tried to be more creative in things, and still, when they came back, the minimum they could come up with was 30 days.
Mm.
Rather than appreciating, he said, I don't like it.
Mm.
I said, what is in your mind, sir? He said, okay, I'll ask you to go and visit Domino's. In those days, Domino's was a new enterprise. You heard about it?
Mhm.
Domino's Pizza.
Yes, 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 yes.
He said, if they can deliver their pizza in 45 minutes,
Yes, sir.
why can't you deliver a customized mobile phone in 45 minutes? That is your
Mhm.
target. Go observe how do they work and try to replicate that work in our system. Trust me, when they got back and they learned that new lesson, that 1 year time was reduced to 45 minutes only.
Wow. Wow.
Now, you could imagine how, have any ideas how they could reduce it to 45 minutes. And what was the lesson they learned at Domino's? How could a pizza be delivered in 45 minutes? That means preparation time and order and preparation time and everything.
Mhm.
Right from order till delivery, 45 minutes. Can we do that with a mobile phone?
Yeah, yeah, potentially.
Right. So in a pizza joint, what they do is to increase the efficiencies, what they are doing is they are seeing that how much time they can reduce in preparation, order taking and preparation.
Mhm.
They fix about 10 minutes in order taking and preparation. A pizza cannot be prepared in 10 minutes. How do they prepare that? They make it in such a manner that they have already prepared items lying in a specific sequence. The most
Mhm.
used items are nearest to the cook, and the least used items, usually which are ordered, they are a little
Mhm.
farther away from him. So in most of the orders, he will just pick this thing from here, this thing from here. He doesn't have to go search for those things in cabinets or something. They are all lying open in front of him. He just puts them
Mhm.
together and quickly puts them into oven, and there it goes. After 10 minutes, the pizza is ready to go out. Then it comes to the rider. Riders are selected in the region,
Mhm.
and it is observed how much they can travel farther. For
Mhm.
example, they can cover a radius of 10 uh, kilometer in 45 in the remaining 30 35 minutes.
Mhm.
So they fix it, they create a circle around their joint up
Mhm.
to 10 kilometer, and they say, okay, we will serve only this community. For serving the other communities, they create other overlapping cells around it. Rather than having only one place to order, they have
Mhm.
multiple joints from where the orders can be received and delivered.
Mhm.
Thus, it makes it possible to deliver them within 45 minutes. If you know what kind of customized requirements are going to come to you, the most
Mhm.
common requirements which are coming, you could keep all that equipment handy and you could put it all together quickly in next 10 minutes, right? And then
Mhm.
you can deliver it in your cell area, which is within the range of 35 minutes.
Mhm.
So that was the formula they adopted, and they were able to do the impossible. So basically, here we are talking about doing the impossible,
Mhm.
just breaking the human barrier. The human barrier was reducing 1 month to 30 days.
Mhm.
They couldn't do better. He reduced it to 45 minutes. That is what really we are looking for. Anyways, what do we want from project management? We want reliable, on time, in full to budget delivery performance, meaning we want more revenues, more profits,
Mhm.
and a happy customer. We want a stable plan, more productive use of resources, meaning resource optimization, which we have
Mhm.
already studied. Simple, objective measures of project progress, meaning we should not have unending meetings, shorter meetings, 10 minutes to 30 minutes, nothing more than that. Better informed, meaning to the point, stakeholders, less waste, more productivity. Don't use them unnecessarily.
Mhm.
Stakeholders must be accessed when they are really going to be productive.
Mhm.
Then simple objective measures of project health check, health status. Again, shorter meetings, better informed, stakeholders, less waste, and more productivity. Same point. Clear signals for when corrective actions is and is not necessary. Better directed recovery efforts, less waste, and more productivity. That is a lean methodology where it
Mhm.
says if you can reduce the waste, you can increase the efficiency. Like you're wasting time, or you're
Mhm.
wasting money, or any kind of waste. There are 8 different kinds of waste recognized by
Mhm.
lean technology, lean methodology. If you can reduce all those wastes, your productivity can miraculously change. Direction for ongoing improvement effort. The future brings more revenues, more profits, happier customer than the present. That means
Mhm.
we have to respect the desires of the future customers because
Mhm.
they are actually forcing us into innovation. And thus we have a chance to learn more, earn
Mhm.
more. But what is happening really in real life? Reliable on time, in full budget delivery, our continuous struggle with time and cost and scope. If you are not adopting anything, any new technique, any new
Mhm.
innovative mechanism, then you are always struggling with time, cost, and scope. And as compared to a stable plan, we are repeatedly rescheduling predictive problem, reschedule, change control, change request. So, in a way, I can say that predictive project management is a traditional project management. It doesn't bring anything new to us. It doesn't have surprises. It cannot reduce the time by, 10 times or 100 times or something like that.
Mhm.
Simple objective measure of project progress. clarity at start and the end. In between, there is a thick fog. About simple objective measures of health check, project health check. Subjective assessments compounded by human factor. People are involved. So naturally, it is not electronic, it is not robotic. So
Mhm.
human factor is there. Interpretation by the human. So that maybe, you have performed exactly the same way, but one person, assesses it in a one way and another person assesses it in another way.
Mhm.
Clear signals for when corrective action is or is not required. Intervening too much too early and too little too late. We micromanage. We don't let the people work on their own, right? Either
Mhm.
we do not check at all or we check on hourly basis. Both are not right. You have to check the health check on a frequent interval. What is right and what is wrong. Direction for ongoing improvement effort will improve our methods when things get better. That is no answer to the problem. If there is a ongoing effort, it must be ongoing. The improvement must be ongoing. You don't have to wait for next project.
Mhm.
So don't spend it ever again. Okay, but generally speaking, these are some of the things. We identify the task in the project and specify the resources. We allocate to each task sufficient time that we are confident will allow it to be completed with those resources. That is the
Mhm.
time the task should take on average, plus some contingency to give us the confidence we seek. That's what we do. We apply task dependencies, that is sequencing, and work out the longest path, which is the critical path. The time along this path is the
Mhm.
timeline of the project. This is our conventional thinking. After we have created the critical path, then we can't imagine this timeline can be reduced,
Mhm.
right? Critical chain method is that innovation, is that technique by which we can do miracles. The things we could be done only in 100 days, we could do in 10 days,
Mhm.
right?
Yeah.
As long as every task completes on time within its contingency, its
Mhm.
successors will be started on time. That is a normal thinking that, we are in a predecessor successor relationship. If this activity finishes, only then the successor start. Why can't we start the successor in parallel or something like that? Although we have a concept of lead and lag, but that is just to be used sparingly. We don't really make such big changes in our project. We don't want to take many risks. As soon as any task finishes late, its
Mhm.
successor will start late. And this normally means they will finish late, and ultimately the whole project is going to be delayed. In order to rescue a project which shows any lateness, we have to squeeze the remaining tasks in the project,
Mhm.
which is a very uphill task. Although that is what we say that okay, we are delayed by 2 days and we can somehow squeeze 2 days out of the remaining schedule, but that never happens. And as we proceed ahead in the life of the project, pressure increases, and it is impossible to meet that pressure. Typically, we have a compromise on time, cost, or scope, and reschedule. So we have to sacrifice something out of these things. If I allow more time for every task in the plan, each task is less likely to be late.
Mhm.
That is a normal thinking. If this takes 8 days, I will give you 10 days. Then it will not be late. It is wrong. Because as I gave you the philosophy that time work expands to fit the time available. So that
Mhm.
is a wrong perception. We think wrong,
Mhm.
right? So we don't have to give extra time. We have to keep extra time.
Mhm.
If I allow less time, the end date will be earlier. but the project is more likely to overrun.
Mhm.
If the project overruns, how can the end date be earlier? End date will be delayed. But I have to deliver a project on time. That is my problem.
Mhm.
So, anyways, this was just a food for thought. How long should we allow in the plan for a task? For example, some staff work more quickly than others. Naturally, that is a perception. So maybe just a wild thinking. If we have people who can work faster, why can't we focus on them rather than focusing on those who are amateurs?
Mhm.
Sometimes staff are distracted and interrupted. Don't we have to deal with this situation? If the staff is distracted, maybe due to overload of work, we can reduce their
Mhm.
overload. We should not interrupt them when they're doing something. When we interrupt them, we actually waste their time and they are unable to complete their work in time. Sometimes necessary resources are delayed. People are working fine, but the equipment or materials they need to use to do their job, that did not deliver in time. So we may have to think about the just in time philosophy that when a job is to be started, all its equipment and materials should be available before that time, that activities has to start. So we have to ensure just in time delivery, right? Why I'm saying just in time delivery is because you could have ordered those things earlier and stored them 3 months earlier. But that doesn't mean that is beneficial because if you store items, it will cost money. You have to maintain them, you have to secure them, and it will cost you extra. It is not an efficient way of doing things. Although most people think that to avoid the late delivery of items, we should buy them beforehand and keep them in store. That means you are increasing the cost of storage and maintenance. So that may not be a very good solution. Some staff are risk averse in their commitments. They they don't want to consider risk, and ultimately risk doesn't respect them. Risk does occur, right? So those who are risk averse, those who do not want to see the risk, they cannot be always right. Risks will occur, and they will cause damage, and then these people will panic. Some organizations reinforce risk aversion, which is a very bad practice. Can't ignore it. Risks are there. You must be conscious about them and do uh, some calculated risk taking exercise. The average time the task ought to take an average performer who focuses on it. Again, the point we earlier talked about that it people have different capabilities. When we calculate the resources for a task, we do not take the slowest worker or an average worker in mind. We take in mind the person who could do it the best way. So, for the calculation purposes, we are always too optimist. But when it comes to hiring, we get the worst of the people and they cannot do their job in the time allocated. That is one reason why the work cannot be done in the time allocated. Plus, the time we expect to be spent on distractions is not considered. Plus, contingency time to take account of the spread between average and low performer. You see, don't calculate on the low performer. At least we must take the average worker speed to calculate the time.
Mhm.
So, because we don't do that, we calculate on the highest performer. So, what we get is between average and low, and therefore they can't perform. Our uncertainty in the average time. When we take the average time, we are still
Mhm.
uncertain. The uncertainty in time for distractions. We don't know how much will be the distraction. So try to
Mhm.
reduce the distractions. How risk averse we are or have to be. We must be, we cannot be blind about the risk. We cannot be overcautious about the risk, but we must be an intelligent risk taker,
Mhm.
calculated risk taker. So that is what is desired in a good project manager. I'll skip a couple of slides to
Mhm.
take you directly to the critical chain philosophy. In project operations, what does it happen? When we use critical chain method, that is a mechanism by which we calculate the buffers, and those buffers actually help us monitor things. That is a protection built into every path. These buffers are going to protect us against delays. So they are going to protect us in delay. So they are our monitoring mechanism. Buffer management is
Mhm.
a monitoring mechanism.
Mhm.
And whatever happens when we are managing buffers, we give the feedback to critical chain. Chain can change its planning, and it can be give a feed forward, and the buffers can be revised. So we can be always in full control of our project, never ever letting this to get delayed. This is basically this concept of critical chain is based on a philosophy or a theory which is called a theory of constraints. I hope I'm not boring you.
No, 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 no. I'm okay.
Okay.
Not at all.
This is a very interesting theory.
Okay.
It says that if actually, let's forget about the project management. Let's talk about the
Mhm.
production environment.
Okay.
In production environment, people usually have delays or less
Mhm.
production, less number of items being produced due to several reasons. Maybe people are inefficient. Maybe some equipment is out of order, or it is underperforming, or things like that. So whenever we have any such problem, we try to make decisions on the spur of a moment
Mhm.
without even considering what is the real problem, what is the
Mhm.
real constraint. For example, our production capacity has decreased during the last 1 year.
Mhm.
So the very first thing which comes to your mind is people are not working well.
Mhm.
So you start spending lots of money on training of your employees,
Mhm.
which may not be required. You don't know what is your problem. You have assumed that it is the people who are causing the problem. So you are spending now a lot of money on their trainings, but still
Mhm.
you are not able to increase your productivity because
Mhm.
the actual problem is elsewhere. You have to hunt that down. You have to identify the constraint. And if you can identify the constraint, that is hitting the bull. Once you have identified the constraint, then you exploit that constraint. For example, you have identified that although the whole supply chain is all right, but one machine, which is part of the whole supply chain, is performing slower than usual. Thus, it is producing less. Every other machine is working fine. People are working fine.
Mhm.
Equipment is all other equipment, materials are fine, but this one machine is the culprit. That is my constraint. And because it cannot produce more than a specific number of items, The further processing, the further machines cannot have input enough to produce more. Yeah, you understand my point?
Yes, sir.
So when I have identified my constraint, I should exploit the constraint because I know I can't improve the situation. The first thing you should do is all subsequent machines should be brought down in their capacity according to the constraint. If the constraint, if all other machines are able to produce 100 items at an hour, this machine is producing only 10 items an hour. That means extra production from the earlier processes is piling up because this machine can't process more than 10. Previous machines are processing 100 items per hour. So every hour I have 90 items extra produced, which are piling up continuously, thus increasing my storage cost. So the very first thing I should do is I should tell everyone that the production capacity has been reduced to 10 items for the time being. Do not overproduce at all. Simply by taking that step, what you have done is you have reduced your storage cost. Thus, a bit of relief you have got. That is first step, exploit the constraint. Identify it. When you find it, exploit it. Meaning, make everything else subordinate to this constraint. Nothing should produce more than this. It is called subordinate and synchronized to the constraint. Whatever is the capacity of the constraint, you should bring everything down to that level. That is a temporary relief. But trust me, in a production environment, this is a big relief. Maybe it is hundreds of millions of dollars. Just cutting from the storage cost. Next, what you should do is elevate the performance of the constraint. Now the capacity constraint is 10. You must try to enhance or improve it to something bigger than that. Because if you can increase it even to 20, your production will be doubled. So whatever you are producing right now, you will be producing double of that. You understand my point?
Yes, sir.
But the question is, before I can elevate the performances of this constraint, I must recognize the next constraint. What if there is another machine which is constrained at producing only 20 items an hour? If I enhance the first constraint from 10 to 50, still our whole production line cannot produce more than 20 due to the second constraint. You understand my point?
Yes, sir.
So I should elevate my first constraint to the level of my second constraint. This is just like, I'm just trying to give you an idea. Uh, the first constraint is basically my project buffer. The subsequent constraints are my feeding buffers. Just, understand it that way. So I will keep improving the situation by every feeding buffer. And one day I will have removed all the constraints and ultimately I am at 100% capacity, 100 items a day. So repeat the process until all the constraints are removed, one after the other, and we are at the critical path, better than the critical path. We can do everything much, much faster. So this is the theory behind the critical chain method. And basically this was invented by Goldratt. The person's name is Goldratt, and there is a book also by the name of the goal. Anyways, so how does it impact our critical chain? Actually, Goldratt initially came up with the idea of TOC, Theory of Constraint, and
Mhm.
later his second book was on critical chain. This is specifically for project management. So the 5 steps in critical chain, very similar to the TOC 5 steps. It says identify the critical chain, meaning the critical path. Exploit the critical chain.
Mhm.
Subordinate other tasks and paths to critical chain, meaning all the other paths must respect the critical path, which is the critical chain. Elevate and shorten the lead time. That is the feeding buffers we are trying to address now. That makes us even faster. And repeat the process time and again. This is the basic diagram for the critical path. Critical chain.
Mhm.
So I'll just skip that. These are just unnecessary steps in that. Okay, this is also based on another interesting phenomena, which is called drum buffer rope.
Mhm.
Drum buffer rope is a philosophy in the base of theory of constraint.
Mhm.
You can see here are the items which are the raw materials. This raw material is fed into this system. This produces something, is fed into this system. This produces something, is fed into this system,
Mhm.
and so on. It flows. But you see, if these two workstations are of same capacity,
Mhm.
so they can consume 2 items at a time and deliver 2 items at a time, and the next station will consume those 2 items and produce 2 items. So this is consistently doing it. But then this third workstation is
Mhm.
slower. It can process 1 item at a time. So 1 item from the previous, we are having a consistent stream of 2 items.
Mhm.
So 1 item is consumed, one is storage. So your inventory keeps increasing here. This is your buffer, right? This
Mhm.
is your inventory, keep building up. And it releases things in a slow stream. This is actually your speed. The finished items can be piled at the end. So actually, it says that the rope is between the raw material and the constraint. Constraint in project management, we call it critical path.
Mhm.
So this is the critical path. We have to we have to process only that much which we can achieve in that critical path. And what we have to produce, we have to align with the speed of the workstation. So if the production capacity has to be increased, this machine capacity has to be increased. We have to drum it up.
Mhm.
And if we drum it up, then probably this buffer is going to shorten. I just wanted to give you a little idea about this
Mhm.
drum buffer rope philosophy. Okay, okay, yes. Here we, right, this is an example of a scarcity of resources.
Mhm.
Task C cannot be started until task A and task B are finished,
Mhm.
right? So it depends
Yeah.
upon both of them.
Mhm.
And the minimum time these 3 tasks will take, these 2 tasks, A and B, can be done simultaneously in 10 days,
Mhm.
and only then the C can start. It will take 10 days. So 20 days is the minimum project time these
Mhm.
3 activities are going to take in your project.
Mhm.
Remember, I have talked to you about the resource conflict. Incidentally, if task A and task B is using the same resource, they cannot be done in parallel. They will be done something like that.
Yeah.
First, task A will be done, then task B will be done. 10 plus 10, 20 plus 10, it will take up to 30 days. That is the real fact. Don't assume that because the dependency is like this, so it can be done in 20 days. This is a misnomer. Actually, due to the resource constraint, we will have to put it after one after the other. Now, if the same resource is being used here and here, we want to be sure that this resource is free from task 1 before task B can be started.
Right.
That is the reason why we need to have a resource buffer. You remember that?
Yes, sir.
I'm marrying up few concepts which we have already studied. So, naturally, to understand the critical chain, to create a critical chain, we must identify the longest chain, which is my critical path of the dependent activities. So take the critical path and create it a critical chain. How do you create it? By generating a buffer out of the critical path or the critical chain. If you can somehow tax all your critical activities to give a share of give a contribution for the project manager's disposal, some time should be reserved with the project manager and they should be taken out from the activities, and that should act as a project buffer. So these activities could have been done in 30 days, and this is a completion buffer. This is a commitment day, end date is this one. So if I have 30 days, buffer buffer is 0. If I want to keep something in the buffer, I have to borrow it from activity A, B, and C. For example, I ask activity A, B, and C to contribute 2 days for the project buffer. So I will have 2 days from here, 2 from here, and 2 from here. They will be my 6 days buffer. This is my protection. Now, every task has 8 days to complete each. Got it? So, even if they do not get completed in 8 days, at most they can be completed in 9 days, or at most 10 days. But, anyways, I am not going to be delayed because I have that amount in buffer, and I will not give anything more than the amount in buffer back to them. Therefore, I will definitely be able to complete it within time. Agreed?
Yes, sir.
Now just look at this. These activities were actually taking 30 days. Now they are taking still 30 days, but the completion buffer or the project buffer is included. So I have accommodated an extra bar of project buffer and shortened my activity durations accordingly. But whole of this thing still takes the same time. So my main critical path shown to the customer is like the upper diagram, but my internal diagram looks like this, where I have got a completion buffer. This is a internal matter to the project. Then, because this we were talking about the critical path only, about the uh, non-critical paths joining the critical path, the points from where they join the critical path is called the feeding chain. So just like we created a project buffer, we must have a feeding buffer for each such non-critical path. For example, this is the completion buffer, the project buffer. These are the normal activities. This is a task D, which is not critical, but when it finishes, it task B gets started. What I do is I even get some time out of this task, put it into the feeding buffer to ensure that task D does not impact the start of task B. And task B is assured to start on time. So to save it from a non-critical activity, I have created a feeding buffer after that activity. Got the idea?
Yes, sir.
If you want to see these buffers in a Gantt chart, you can observe these uh, green bars. These are my various buffers. Like this is a time buffer. It comes after the electrical engineer has started working. So, I mean, this is not exactly activity based. This is resource based, resource buffer. This electrician is required to be employed on another activity after he completes this job. So after he completes this job, uh, uh, he has a buffer. And this buffer is the resource buffer. Before he can come for this activity, he should be available this much time earlier. He should be ready. He should not be unavailable. He would be on duty. I'll pay him for 2 days extra. But that is my protection. That is my resource buffer. That way you can see we can have these kind of buffers for inspectors, for fabrication, for so many other things. We have a great plan in execution. What can happen in execution? We don't know, but we have built a strong protection. Our defense line, by this critical chain method, our defense line is great now. Nobody can break our defense. You understand my point? Until and unless it is something completely unforeseen, something drastic, something like a crisis, like a hazard happens. Anything which is bigger than the project, it naturally could not be controlled in the project. Okay, let me move on and see if there is anything important there. There is a little bit more discussion about the types of buffers, project and feeding buffers. Well, these are the methods. First method is 50% of the chain. Says, well, it is your decision how much you want to keep in the buffer. But because of the fact that people do have unrealistic estimates created, like padding done, so keeping that into consideration, one method is cut everything into half. Cut every activity duration into half and take the half under the patronage of the project manager as a buffer. Well, this is not excluded from the project. Project manager is gaining more control over those resources. Although you have made the life of those workers a little bit difficult, that they have to do the same job in half the time is a challenge, but they won't be able to meet it. But we will still be able to kind of keep granting them a little bit of time, and ultimately we will ensure that they be able to do the job. This is a safe approach, 50% of the chain. You should not count gaps in the chain when using this method. For feeding chains that branch upstream, you should consider only the longest path, meaning that basically the critical path is only having the project buffer is only meant for critical path.
Mm-hmm.
No other path can claim the reserves or the buffer items from the project buffer. Project buffer is dedicatedly reserved for the critical activities only. How about the protection of other activities, non-critical? They have their own buffer. So on every path, a non-critical path, there is a buffer. That buffer will protect non-critical activities of that path. So practically speaking, all activities are covered. But one thing, we established the rule that the project buffer is never, ever to be used by any non-critical activity. If they want to consume, they consume their feeding buffer. They don't have permission to consume the project buffer. Got that?
Yes, sir.
This method has two strengths. It is simple, no calculations required. We have just
Mm-hmm.
established a rule that just cut everything in half. It's a very simple rule. And it gives you better control, right?
Mm-hmm.
It usually provides a large enough buffer. Means almost half the duration of the project is in the buffer. Although it looks unrealistic, but this is very
Mm-hmm.
controlling, a very good control. But the weakness of these methods is the primary weakness is that it does not allow you to explicitly account for known variations in the task.
Mm-hmm.
It is just an arbitrary method, right?
Mm-hmm.
This method also creates relatively long duration buffers, big buffers on long project. If there is a very long project, it's a 5 years project, the 2.5 years is in the buffer, which some people
Mm-hmm.
find difficult to justify. So that is probably the reason why we don't usually use this method. But one thing is very sure that this is pretty good method. Other method is a little tricky. It is called square root of the sum of squares, SSQ. Square root of the sum of squares. Little
Mm-hmm.
technical. SSQ method uses information on the low risk and mean duration for each task in the chain.
Mm-hmm.
It sizes the buffer as the square root of the sum of the squares of the differences for the tasks along the chain. As with the above method for feeding chains, same way you can create the feeding chains as well. Advantages, primary advantages of this method is that it allows using known task variation, meaning it is not ad hoc. It is based on this formula.
Mm-hmm.
Uses information on low risk and mean duration. Low risk and mean duration. Now it has a reason. It allows using known task variations. Disadvantage is it may lead to undersized buffers for long chains. As in the previous method, we had a long buffer. In this case, we may have a very small buffer. So smaller the buffer, smaller is your flexibility. There are two primary reasons for using it. First is underestimation of the actual task variation. Second is that this method assumes that all project variation is stochastic and reality demonstrates that some is not. Well, to cater for that variation, things are not going to happen as we assume they happen. It could have a varied kind of results. So, to accommodate that, probably this method is a better method than the first one. Uh, as far as the bias is concerned, some project variation is a result of a bias, right? No, biases impact us a lot. Our boss has a bias. He thinks in a different way. So we tend to plan according to his bias, right? This is something. Things that can make projects take longer, but not make them shorter. That is a bias. That is the impact of the bias. The path merge bias is one obvious bias in this category. That the statistical basis of this method does not work for variation that includes biases. Method 3 is bias plus the use of SSQ. Well, this is a little more technical. You need not know all these methods. Project managers usually don't know until they are using the critical chain. But I would like to introduce you to these concepts as if you ever deal with the critical chain, you would know that we have talked about it. This method combines the previous two using the fixed buffer method amount to the account of variation, summed with the SSQ method to account for common cause variation. So we are trying to get the best of both the worlds. Fixed amount will usually be significantly less than 50% of the chain. So this is a kind of a middle method between these two. It is the your buffer project buffer is not going to be 50%. It could be less than 50%, 70%, 80%, something like that. But it is still better. So rather than be very calculative and using the SSQ method, I would rather like to use this combination of bias plus SSQ. Okay. Here it shows the ITT approach, which is a buffer of 19 days. Let us see what happens there. Act, watch and plan, and okay. We have a buffer of 19 days. We have 7 days remaining in that. If we start this activity on 8th day, we can complete in 13 days. That is my plan. And the latest I can do it is from 14 to 19 days. I mean, I can slide between the buffer. I can do it in the last couple of days or first couple of days. I have 3 brackets, right? So this could be done like this. Similarly, the same approach could be followed in the feeding buffer. But anyways, I think this is not really very important, but we do have a good understanding of what we are doing. Okay, causes of biases. For example, we are using bias plus SSQ. Omissions, we have forgotten doing something, some error. So range of time buffer should be kept not to exceed the cost impact. You can't keep a huge time buffer if the cost impact is not great. Range of cost buffer is 5 to 10%. If I have to appropriately allocate additional time or the buffer for this omission, I cannot keep a buffer which could cost me much more. 5 to 10% is the range. Path merging, meaning the feeding path and the project buffer, feeding buffer and the project buffer, how can they merge? More than 5 parallel paths are existing. So up to 20% should be the range of time buffer. That means if 5 paths are making up the 100%, they are entering into the critical path. So these
Mm.
five will cater for 20% of the whole. Each one will carry the load of 20% weightage. 100 divided by 5.
Mhm.
Errors, 5 to 20% cost buffer and time buffer. Special cost variations, 0 to 30% time buffer and cost buffer. Actually, the idea of buffer is not limited to time. It is also, we can control cost with it.
Mhm.
Therefore, we have the concept of cost buffer. Failure to report necessary rework, we have got 0 to 20% in time buffer. And uh, as far as the cost buffer is concerned, we will consider that errors 5 to 20% caters for the failure to report necessary
Mhm.
rework, right? Anyways, this is just a thing which you could use in your project if you're seriously
Mhm.
using one of these methods.
Okay.
Uh, the second one, the SSQ, no, I have done that. What is important here? ABC. We have already discussed this thing. Now that, yeah, it's the same scenario we have seen before. This is my
Mhm.
project buffer. This is my feeding buffer.
Mhm.
And it says that at day 5, task A has 8 days, meaning we have consumed this much buffer.
Mhm.
So this much buffer has been taken out of this place. And this activity, task D, is completed, no effect on completion buffer. Meaning, if this D activity
Mhm.
did not end in time, this was having a float.
Mhm.
So if it got delayed within the float, it has no impact on the project buffer. But if it exceeds that, we already have a feeding buffer to protect us
Mhm.
against
Mhm.
that,
Mhm.
right? So that was the
Yeah.
point here. How many days work until the project is completed? The number of days left on the critical chain, right?
Mhm.
What do you understand with that?
Um, it's time the critical chain.
How
It's the
much more
time.
time do you need to complete a project? That means the remaining time plus the project buffer.
Mhm.
Because for the customer reporting,
Yeah.
project buffer is part of the project. That is an internal control that we are
Mhm.
exercising the project
Mhm.
buffers and feeding buffers. But when we have to tell to the customer how much more time we need to complete the project, we would tell the actual estimate of the buffered activities plus the whole buffer, the remaining buffer, right?
Mhm.
Like in
Mhm.
this example, this was the total buffer, and this was consumed. So this is my remaining buffer.
Yeah. Yes.
So
Yes.
if I have got B and C remaining, so I will add B plus C plus the remaining buffer. This
Correct.
is the
Correct.
this is
Correct.
the remaining project time.
Mhm.
Okay. We compare the percentage of the completion buffer remaining. We could call it CBR,
Mhm.
and with the percentage of critical chain remaining. Completion buffer is for project buffer, right? You can use the word project in place of
Mhm.
completion. This is a project buffer, and critical chain remaining, that is the remaining, in this example, this is the critical chain remaining. No, sorry. Critical chain remaining is this, and this is the remaining buffer.
Mhm.
This is the consumed buffer. So if CBR divided by CCR is equal to 1, that means we are in green zone, that we are not off. We are exactly right.
Mm.
If CBR divided by CCR is 1 or more than 1, project is in amber. Prepare a recovery plan. If CBR divided by CCR is less than 2/3, that means project status is implement recovery plan. I mean,
Mm.
if you are exercising critical chain, you could use this traffic light symbol
Mm. Mm.
to indicate if you are going all right. This could be your critical chain applied on your project. So this could be something like that. In a 2D, we could show these colors like that. Completion buffer remaining and critical chain remaining. So green zone is all fine with us. So completion buffer is 100% available and critical chain finishes, meaning without consuming any buffer, I complete the project. So I complete it much earlier. That is
Mm.
distance from here to here. As we start consuming the buffer, our critical chain remaining keeps reducing until we have consumed it all. If we consumed it all, we are on time. Our project will be completed as planned. But if we are here, we are saving the whole duration of the project buffer. And if we are somewhere in between, then we are still saving some time. But the chances of getting delayed are almost negligible in a
Mm.
critical chain. Let me see if there is something important here which we can discuss. Okay, let us try to make a head and tail out of this thing.
Mm.
Product 73 schedule, 793 schedule, specs, design, and test plan. This is one. Pacing resource schedule, design 792, design 793. The 793 project is this one. And this is 794 project. Its design is this one. So they are ordered in that manner. And we are keeping a resource buffer in between each. We are ensuring that before I start any design, the required resources for that doing that design work are available beforehand. So I'm ensuring a resource buffer here. After every activity, I have a resource buffer. And that relates with my overall plan. This is one activity, 793 design, 794 design, 792 design, and this is not actually part of your Gantt, your sequence diagram. This is not part of that. This is a imaginary connection, like the dotted line or the red line
Mm.
I drew to show how a resource buffer will look like. So this is basically that imaginary diagram. Okay. Let us look at the buffer management thing. Management team looks at pacing resource schedule, resource buffer status. And this is specifically we are talking from the resource buffer point of view.
Mhm.
Critical change versus completion buffer, meaning I said whenever you read completion, you read it project buffer.
Mm.
So critical change versus the project buffers. Resources Best resources allocated to most important projects. That is through this resource buffer. Pacing resource task in progress for early completion and pacing resource task due to early start. Re- Record buffer erosion to focus improvement effort. These are advanced terms. If you are actually doing the critical chain management, then probably you will learn about how buffer erosion can be avoided and things like buffer erosion is consumption of buffer, quickly consuming it. We don't want
mm,
that. We don't want the buffer to erode. So record
mm,
buffer erosion to focus improvement effort as if how can we can heal our buffer. For multiple projects, start with all projects fully defined in CCPM. You have to create a CCPM for all the projects. Identifying pacing resources, which resources spared from one project and now can be used on another project. You actually have to do resource buffering uh, amongst many projects. It is not just one project we are talking about.
mm,
Our resource, when gets free from one project A, may be required by project B. So that level of critical chain can only be exercised through the resource buffering at multi-project level. Apply the hierarchy of subordination. Same rule. You remember we said that
mm,
first identify a constraint, then subordinate, then uh, you know subordinate all other processes to that. Manage by buffer management and use buffer management to drive improvement. And trust me, this is a continuous improvement kind of a thing. There is no failing in critical chain.
mm,
There is a very less chance that you will ever get delayed. If you don't exercise this, and most people don't, if we haven't identified the pacing resource, when you don't have a good control over your resources, you don't have a resource buffer, our pipeline may be infeasible. We will waste capacity. Without a resource buffer, the pipeline won't be robust. Without good measures, management is unfocused and wrongly focused.
mm,
Without buffer management, improvement is unfocused. There is no continuous improvement. It
mm,
would be ad hoc improvement. Sometimes it is, sometimes it is not. Sometimes you see it, sometimes you don't. In practice, the logic of CCPM works. It is practical. There are many success stories like these projects listed here. Uh, Implementation is not a trivial undertaking. It is not for a light-hearted or a person not really aware about how it is done. You must have proper training to use this technique. As CCPM brings project under control, and I would say under definite control, the constraint moves to management. Meaning, you see, as the buffer moves to the project manager, so project manager exercises his or her power on the buffer. So
mm,
they own it. They can take decisions about it. When the buffer was not with them, it was with the team members. Team members
mm,
were enjoying it. Now the project manager can use it to manage the whole project delay. Aggressive reduction in cycle time are both possible and necessary. We should be able to do things faster.
mm,
Yeah, this the name was Eli Goldratt. Is this the
mm,
person who gave the concept of critical chain and theory
mm,
of constraint? There is another important book by Lawrence Leach, Critical
mm,
Chain Project Management. Very interesting because although I respect Eli Goldratt for his
mm,
basic concept, it's very enriching, but some people have written books on this subject further and further elaborated it. Enterprise Focused Management by Ted Hutchin also talks a little bit about these things. This is our critical chain management. And any questions?
So far, so good. Thank you, sir.
Okay. So before we can start the next portion, we can
Mm,
again have a break of
okay.
15 minutes.
Oh,
Here you go.
okay. Thank you, sir.
Welcome.
Mm.